So this is my first question, and yeah, I'm going to count till 5, and you please pause the video and try to come up with the answer, and if you don't know what is the answer, I will explain in the end. So I'm going to count till 5, you pause the video. 1 2 3 4 5. So I think you would have paused video now, maybe you got the answer by now. So let's compile this code. We have compiled it successfully and ran. So the answer is 11 and 11. This might be surprising for so many people because they were expecting this 11 and 10.6, because if I'm calling this add with 10, then this function should be called here, and if I'm calling this add with 10.5, then this function should be called here. Okay, there is no role of this function actually. I have just kept it like that. No need to keep that actually. So first of all, try to understand this whole thing. There is a class which is inheriting this class, and this class is having this add function, and this class is also having this add function. In that case, what generally people think, if you are inheriting, then this function is coming here in 2, class 2. Yes, it is coming, but the scope doesn't come from here to here, and this function overloading work in case of scope only. So to give you an example here, suppose you have some function like function, and you have this integer, and another is function with double. Okay, so here you see you have achieved function overloading just because these two functions are lying in the same scope. This function is not lying inside this 2 or inside main, and this function is not lying in somewhere else. No, they both are at same place. That's why you are able to overload that. Okay, that's where the overloading concept comes. Okay, and here 2 is a different scope and 1 is different scope. Even if you inherit, the scope doesn't comes, and if you want to see how the scope will come, you watch my next video, which is a follow-up video of this one. There I will explain how to get the same scope and how to get this answer. Okay, so for now this is the answer. Okay, so I will see you in the next video.
This question is based on today's comment. Somebody asked me that, can we make this main function as friend? I mean, this is a main function and we are declaring it as a friend inside our class and trying to access this b.x. This x is as private inside this class, so we will be able to do this or not. So this was the question, and there is no problem in this code. The only problem is, can we make this main function as friend inside this? And let me give you a hint here. This main is a special function. We all know that this is the first function which is called when this exe will execute. I mean, operating system will search for this particular function, but it is a function, right? And we can create functions as friend. But again, this is a special function. Maybe compiler won't allow you to do that. So I'll count till 5, pause the video and try to understand this. 1 2 3 4 5. I know there is nothing to understand this. So let's compile this. Voila, this is 10. So the answer is 10. So there is no secret that you can create main function as your friend. And don't think this is a good practice, because you might think that, okay, I will create this as a private and include it here and declare myself as a friend and I can access that. And some people might think that, then what is the use of making your class data members as private if you can do this? So let me tell you that you are the creator of your class. I mean, you are creating this class, not somebody else. So it's you who will give all the rights and everything about this class, and you ended up doing this. So it's okay. We have that much freedom. So we can create main function as friend function inside your classes. Okay. So if you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this.
Hello friends, this is Rupesh and I'm watching CPP Nerds video series on C++ MCQ questions, and this is one of the MCQ question. Actually, I'm not giving any options here, but this is like what would be the output of this program. And don't think that this is some silly program. It will clear very big concept of yours. Okay, so let's start this. So before I start, you pause this video and try to come up with the answer that what would be the output of this program. Okay, I think you would have paused your video and come up with the answers. So let me tell you how it should be. So I mean, what you might have thought. So we have this base class and b1 is created, it means it will call this base default constructor. So it will print default first. Okay, so let's write that default, and then it is passing this b1 to this function. So there is this copy involved because we are not taking it as a reference here. That's why this copy constructor will be called. So let's write copy here. Okay, then after this copy, we are assigning this b2 into this b3, which is another copy constructor call. So let's write another copy here. And after that, we are returning this b3 and assigning it into b4. So this is also one copy constructor. We all know that, right? Okay, so this is what you might have thought of. But no, this is not the correct answer. Okay, so let me just compile this. First, let's comment this and compile this. See, the answer is default copy and copy. No third copy is there. So that third copy was coming because we were thinking that this b3 will be initialized inside this b4, but it is not doing that. There is only one default constructor, two copy constructor call. Default for b1 and first copy call is for b1 is being assigned into this b2, and second copy call is b2 is initialized into that b3, but this fourth is not necessary. This b3 is not initialized inside this b4 because your compiler is very much intelligent that it can see that at last whatever you created inside this function, you want to copy that inside this b4. So whenever you was creating memory inside this function, that memory was not of this b3, that memory was of this b4 here. This is some magical stuff compiler does, because it is very straightforward that whatever object you are creating, you are returning that object and initializing into some other object. So why not create that object on that particular memory? So we will save one copy constructor call like we are saving right now. And if you are still confused, let me just remove this and let's remove this, and we can just simply return this b3 from here. Okay, so this should be very clear, right? Like you are creating this b1 and then b3 is being returned and initialized into this b4. So this is one time default constructor call, this is another time default constructor call, and this is a copy constructor call because you are copying this b3 into this b4, right? But that copy will not happen. Let's compile and check that. See, it is two time default only. First default is this one. This is obvious. Now you are calling this function and trying to create b3, but b3 was not created, b4 was only created inside this, and there was no return from here. And let me tell you what is this topic. This topic is called return value optimization. So if you don't know what is return value optimization or non-return value optimization, which in short form it is RVO and NRVO. So I have a video for that. You may be getting the link for that video somewhere here right now. So you can click that video link and understand this better, that why compiler does like this and how it does that. Okay, and how to stop compiler from doing this, because sometime what happens, you don't think like this and you may end up debugging your program with some different mindset. Okay, so compiler is doing some stuff in the back end, you're really not aware of that, so you may not debug your program the way you want it. So when we debug our program, we turn off that. That is the convention, so that we can really understand what is happening inside that. Okay, so thanks for watching. I hope you like the video. Don't forget to hit the like button, guys, and share this video and see if your friends can solve this, and it will be very helpful for your friends also. So please make sure you share these videos, and I'll see you in the next videos. Bye bye.
So try to think about the question here and pause the video. I think you'll come up with the answer, so let's compile this. This is C++, this is 10. There is no compilation error, I know that. Yeah, so if you run this, the answer is 21. So answer is 21. We all know why it is 21, because you are having this function, you are calling this function with this x. Okay, not this x. It is this x. Okay, and you're passing this and taking this as a reference. So reference means you're pointing this x itself. Okay, even though you're not passing the address of this x, but you're getting that x as a reference. So in that case, you're pointing at this x itself. Okay, and incrementing that x, whatever that x is holding means 20, and you're making it 21, and after that you're coming from there and we're just simply printing this x. Okay, so whatever you are doing here, everything is on this x, not this x. Okay, so if you want to access this particular x, you have to apply a scope resolution operator. Okay, so if you pass this one, so you're telling that I will be looking for x but not in the global scope, I mean local scope, I will be looking into the global scope. Okay, so this tells that. Okay, so if you'll compile this now, you will be getting a reference of global and you will increment that variable and we can print that. Okay, so let's compile this. We compile this, there's no problem. If you run this, 11. Okay, now it is 11 because here you passed x, but this x is now this x. Okay, so I think you're clear now. Let's look at the next question now. This question is about constructor calls. So pause the video and think about it. I think you would have got your answers by now. So let's go ahead and compile this. There is no compilation error. If you will run this, the answer is Constructor call. So one time constructor is being called. So the answer is A here. Few people might think that if you are not giving any parameters like this, in that case, this is a default call here, but it is not. It is actually a function declaration here, and this B2 is a function name, and this base is a function return type. Okay, and this function is not taking anything. Got it? So I can just simply write like this. It will take void or it will take integer. Okay, so something like that. If you will compile this again, it is going to compile and run the same thing. Okay, so sometimes this gets tricky when it comes to 0 values inside this parenthesis. That time we think if there is no value, it will call to this default constructor. Okay, so let's look at the next question now. Hello friends, welcome to another C++ MCQ question, and this question is about static functions here. Okay, so pause the video and think about it. I think you would have got your answers by now, so let's check it out. This question is 101. So the problem is this constant here, so it means it's a compile time error. And why it is an error? Why this const cannot be in this static function? And the reason is this static function is not allowed to access non-static data member. So if you will put it like this, so this is a non-static data member, you cannot access that here. Like you might be willing to print that, so you cannot do this because this is a non-static data. Okay, and remember this constant was for non-static member functions, and why we use that constant? Because we don't wanted our data members to be changed in those functions. Okay, so there is no purpose of using constant in static because static functions can only access static data members, not non-static data members. Okay, and this constant is for non-static data members, not static data members. Okay, so I think we're done here. Let's look at the next question now.
Hello friends, welcome to another C++ MCQ question, and this question is not exactly a C++ question, but I'm using this reference here, so in that case it is becoming a C++ question. Okay, so let's understand the question here. You are having this variable x equal to 20, you're passing this variable x into this and getting as a reference here, which is making this one getting your x here. Okay, so just try to understand this. I will count till 5. Pause the video and try to understand that. 1 2 3 4 5. I think you would have got your answer by now. So let's compile the code and get the output. Your code is 12, right? Output is 100. Why it's 100? Because you're calling this x is equal to 20. X is getting here, which is this x only, because you're getting it as a reference here, and you're checking whether it is equal to 100. No, it is not equal to 100. Then you will go and increment this by 1. This is a little weird syntax, so I will just simply write it like this. Okay, so you can have it
I mean, you can increment it by 1, and you will again calling yourself. So in that case, 21 will go, and you will keep on sending yourself until you reach to the 100 value. Okay, so this is a recursion. So this is printing 100 just because this x is nothing but this x. Okay, so if you will remove this reference, then the answer would be 20. Okay, see, answer is 20 because this x is not getting changed here. This x is the copy of this x, which is nothing but the temporary for this function. Okay, so let's move to the next video now.
Hello friends, this is another C++ MCQ question, and this question is about this delete and new operators here. So have you ever seen like delete new girlfriend? I think you would have got your answers by now, so let's check this out. So there is no compilation error, and the answer is girlfriend constructed, girlfriend destructed. Okay, so this is a perfect code because new girlfriend, this code will give a temporary object and you are deleting that temporary object on the spot. So construction and destruction is happening in the same line here. Okay, so this is a valid code. There is no error in this. Okay, so let's look at the next question now. Hello friends, this is another C++ MCQ question, and this question is a little bit interesting here just because this one, see the syntax here. So whether it is going to compile or not, let's check this out. So before that, you pause the video and think about it. I think you would have got your answers by now, so let's go ahead and compile this. So now we'll compile. This is 103. There is no compilation error. If you will run this, there is no problem. ABC is there. But this is a little bit confusing here, so let me write this. And we'll compile this again and run this. See, the answer is ABC here. So what do we understand from this? The understanding part is your variable name and class name can be equal here. See, A, B, B, C, C. And you're printing that and it's working fine. Notice that we are calling this member functions of these classes here. Okay, so this is a valid code. No problem in this. So we're done here. Let's look at the next question now. Hello there. Welcome to another C++ MCQ question, and this question is about keeping a class name main here. Okay, and you are going to create an object of that. So is it allowed? You pause the video and think about it. I think you have got your answer by now, so let's check this out. So the question is 104 here. No, it is not allowed. If you are keeping your class name as the main, there is an issue. So to solve that issue, we can write it like class main and then our object name. So in this situation, this will compile. Let's check this. If you will compile this, see it is compiling and the answer would be 10 here. Okay. So you can create main class and create objects like this. There won't be any problem in this. Okay. So we are done here. Let's look at the next question now. Hello friends, welcome to another C++ MCQ question, and this question is very simple here. So try to evaluate it. Pause the video. I think you would have got your answers by now. So let's check this out. You might get surprised. I know that. Let's compile this. And the answer is this. RUPE. So EPUR. So the answer is F here. Why? Let's check this out. This Rupesh is going here as a constant character pointer, and we are checking the size of the str variable, which is coming as 4. So this is coming as 4 here. Why 4? Just because this pointer is always of size 4 bytes in 32-bit operating system and 8 byte in 64-bit operating systems. So this is 4, but we are printing it from 3 here because this minus minus would make this str length 3 when you will execute this statement. So in that case, 3 will come first. So that's why this 0, 1, 2, 3 E is coming first here. Okay, E is coming first, after that P, U and R. Okay, it was not that tricky, but the moderate one. So let's look at the next question now. If you have any doubt, please comment out. Hello there. This is another C++ MCQ question, and this question is about the size of operators with this arrays. So pause the video and check this out. I think you would have got your answers by now, so let's check this out. This is G++ and 106. There is no error. Don't look at the warnings here. So the answer is this: 12, 12, 4 and 3. So this is giving you 12 here, this is giving you 12, this is 4 and this is 3. So we all know about
from here to here, because this is integer, so 4, 4, 4, it is 12. This is boolean, so it is having one size, so 1, 1, 1, 1, that's why it is 4. And this is character, so 1 byte, so 1, 1, 1, 3. So that's why this 3, 4, 12 is okay. But what is this first 12 here? I mean, how this thing works, we'll check this out. Okay, so let's assume you are having this array here like this. This is A here, 0th position, 1 position, and 2nd position. So 0 position will have address of this C++ character pointer. Okay, so this character pointer is stored somewhere like this, C++. So the initial address would be something like 0, 1, 5. Okay, so that 0, 1, 5 is at this 0 location here, 0, 1, and 5. So this is at 0, 1, 6, 0, 1, 7, and there is this null character here. So this is the null character. After this null character, this MCQ will start. So it is like MCQ, and then again one null character and this question. Okay, so it is like this. So this one will hold this value. So what is this? This is 15, 16, 17, 18, and this is going to be 19 here. So 0, 1, and 9. And what this will hold? So if it is 19, 20, 21. So this is like 0 and 21. So this is how it stores the address of your string in your array here. Okay. But why it is giving 12? The reason is your pointers are of 4 bytes if it is 32-bit. If it is 64-bit, it is 8 bytes. So mine is 32-bit. That's why it is 4 bytes. So this 4, 4, and 4 all together become 12. Okay. That's why it was giving 12 here. And this is how it's stored. So 0th location will store this value. And when you are going to print it like cout and using this operator, if you will be printing it like 0th position like this, it will go from this address 015 till this null terminator. That's why it is going to print you C++. If you will give 1 instead of 0 like here, then it will directly start from this 019. So this is 019 and it will go till the null here. Okay, so that's how this whole thing will work. So I think we are clear here. Let's look at the next question now. Hello friend, this is another C++ MCQ question, and this question is a little bit interesting just because of these two lines here. Okay, so pause the video, think about it. I think you would have got your answers by now, so let's check this out. This is C++, and the question is 108.cpp. There's no compilation error, and the answer is 3040 here. So what is happening here? We are simply creating this number class variable and passing these two parameters, 1 and 2. So it is being initialized as x and y. It's okay. Now you are calling n.getX and getY function on this object n. Okay, you are initializing that reference, whatever is coming from this x with this 30 value. Okay, so here you are getting the reference of x and reference of y. Okay, not only the values. So that's why if you are going to assign any value, that would get assigned to the original variables here. Okay, and ultimately that 30 is going to this x and this y, but these x and y are totally different than these x and y. Okay, so I think we are clear. Let's look at the next question now. Hello there, this is another C++ MCQ question, and this question is about this private inheritance here. Okay, so we are creating this z object, we're calling this z. So this is coming here, we're calling this x here. So instead of this call, we are calling this one. So check this out. Is there any problem in this code? I think you would have got your answers by now. So let's check this out. This is 109. Oh my god, there is a compilation error. And the error is just because of this x call. Why? Because we are inheriting in private mode. So if you will inherit in protected mode, it won't give any error. Let's check this out. See, and the answer is x called. Even if this x is inherited as protected, you are calling this call from z here, and that's allowed just because this call is a public method here. Okay, if I'll make this private, it won't work. Let's check this out. See, the same error. But what do you think? If I'll write this protected here, what do you think? What should work here? I'm telling you, this protected is all the way accessible in the whole inheritance hierarchy. Okay, so all the way down you can access this protected member. Okay, that's why generally people tell that don't make protected data members. Okay, because they are accessible throughout the inheritance hierarchy. Better you create protected functions like this and keep the data member as private and access through these functions. Okay, so just clear the doubt. We'll compile this. So it is compiling and we'll run this. It is running and the same answer is coming here. Okay, so the problem was private inheritance. So let's look at the next question now. Hello there. This is another C++ MCQ question. So pause the video, think about it. I think you would have got your answers. So let's check this out. This is g++110.cpp. So there are two errors here. One is this, it is telling that x is private within this context. So this is a private, so you cannot access it like this. And another one is derived does not have any field named x. Okay, so it is telling that you cannot use initializer list, which is this one, on x because this x is not the part of this derived class here. So if I'll make this public here, let's make this public so that it will be clear what I wanted to convey here. So this is public. Now let's compile this again. We'll compile this. So this time the only error remains is this one, derived does not have any field named x. So if you want to initialize this x inside this, you cannot use this initializer list because this x is not the part of this derived class. This is part of this base. So for that case, either you call the base constructor, which will initialize it like this. I'll show you. If you will call it like base, then there is no issue in this. We can compile this and this is going to compile and we'll run this. The answer is 10 here. And the second option is, instead of using this initializer list, we can simply do like this. Okay, so this is also a valid code. We can compile this, we'll run this, the answer is 10 here. Okay, but the point was you cannot use this initializer list here to initialize x because this x is not the part of this derived class. This is part of this base class. Okay, so I think we are done here. Let's look at the next question now.
So try to find out the correct answer for this one. Let me help you something. This is a perfect use of virtual behavior in base and derived classes. See, we are having base pointer and having derived object. Okay, and simply we are just calling the derived constructor, base constructor. The only thing I have changed is I'm calling this function from derived and base constructor. So base is also calling function and derived is also calling function. So at what time what function will be called, you have to determine that. Okay, so think about it. I think you have got your answers. So let's compile this. Answer is B. Okay, first it will call base and then derived. Okay, why it is like that? Why it is not working as it should have worked? Okay, because we know that we should have a polymorphic behavior like so. First, okay, let's start with the beginning here. See, you will create this base pointer. So for pointer, no constructor will be called, but we are creating a new derived. This is an object, and for that we need to call a derived constructor. But we know that if we have some base class, then we have to call that base class constructor first before calling our derived. Okay, so derived internally call base constructor. From there we are calling function. Okay, now the question is, this function would be this one or this one, but as we know the answer, it is this one. And the reason is, as I said, because of this we will call derived. We call derived, but derived constructor was not executed. Okay, so that virtual pointer was not updated here. Okay, before that only you called base class. So in that case, base class function will be called. Okay, if you still don't understand, let's go with the diagrams. So let's talk about the working of virtual keyword. So we know that if you are using virtual keyword in your program, we will be having something called virtual table. Let's call that table T1 for base class, and you will be having so many entries in that, but for now we are having only one function, so we will have base fun. So only this entry will be there inside virtual table, and the similar table will get created for your derived also. So let's call that T2. And the thing is, whenever you create derived and you are deriving the base, and base is having virtual keyword, so you will have your own table and you will directly inherit everything whatever is there from here to here without questioning anything. Okay, so let's do that. So base fun. Okay, so this is what happens till compile time. So your code is compiled and things are looking like this. Okay, now you are going to run your code. So running will include this constructor call. So we know that this one will end up calling this function, but the rule says before calling derived you have to call the base. So from here you will go here. Okay, and you will call base class constructor. You will go inside this, you will find function. Now notice this point, you are a derived object, so you will be pointing to this table, not this table, and for you still the entries are base function. Okay, so if you want to call function, you only see this base function. Okay, this entry will get overridden when you will come back from there and you will go inside this function. You didn't go inside this function, that's why this entry is not updated yet. Okay, you called this derived, you came here, from here you directly went here, and you are calling this and your entries are still like this. Okay, so this function will end up calling base function. So that's why this base was executed. So you executed this function, you came back from there, you went inside. As soon as you start executing your derived constructor, your entries will get updated. And the update rule is like this: whatever the function you are inheriting inside your T2 table, if the definition of that function is available inside you will update that entry with your own function address. Okay, so we will override this function here. So let me do that, and now it will be derived. Okay, so as this table entries has been changed, now you will call this function, and now you are looking at this table entry and you will find that okay, I am supposed to call function and this is the function. So this function is a derived function, so you will call this derived function. So this is very simple. Derived class construction, you came from here to here. This is first execution, this is second execution. Till that time your entries was not updated. You will come back, you will update your entry, and then you will call your derived function. So it works like that. Okay, I think you got the point now. Thanks for watching, and next look at the next question now.
So this is another question. Try to understand this question. I will count till 5, pause the video and try to understand the answer. 1, 2, 3, 4, 5. So I think you would have got your answer by now. I'll just compile this and we'll get the answer by. And what is this number? 13. It is compiled successfully, so that it is not a compile time error. So the answer is 21. Why answer is 21? We'll see that. You are getting this x, passing this x into this add function. This add function is taking this x as a reference, which means this x originally passed to this, and this increment is happening on this x. Okay, so that's why it became 21, and now you're passing this x, which is nothing but this x, into sub function, but here you are not taking as reference here. So this x is created temporary. Okay, in that case 21 was passed here, but this 21 is not this x. Okay, so this is a temporary, you decremented a temporary object and you come out from here and you will come out from here, and you are just printing that. In that case you end up printing 21, okay, which was the result of this one. So yeah, if you have any doubt, please ask the question. Let's move to the next video.
Hello there, this is another C++ MCQ question, and this question is about this assignment operation here. Okay, so pause the video, think about it. I think you would have got your answers, so let's check this out. There is no compilation error. If you run this, this is the answer. So D is the answer here. So if you're confused why D is the answer, why not B, this is an array of
2 size and we are copying Q1 into Q2. So in that case, Q1 is having this array of 2 size and it will copy one by one. So whenever it will copy the 0th location, this function will call first location, then also this function would be called here. Okay, that's what is being called 2 times. So if we'll write like 5 here like this, and let's compile this, get copied 5 times. See, 1 2 3 4 5. So it was a little easier. Okay, let's look at the next question now. Hello there, this is another C++ MCQ question, and this question is a follow-up question of this 112 question. So before this we saw this one, now we will look at this one. Okay, so pause the video, think about it. I think you would have got your answers by now, so let's check this out. If we will compile this, there is no compilation error. Let's run this. So answer is again D here. Why not these 4 times? Because we are having this, if this is equal to address of A, okay, then return this pointer. So what is happening here, we are assigning Q1 with Q1, which is self-assignment. So this self-assignment is being checked here, that's why we are returning from here. Okay, so instead of printing, we are just simply returning the same pointer here. Okay, so that's why you are getting this assignment operator call for this assignment, not for this assignment. Okay, so if you noticed here, you would have caught this very easily. So we are done here. Let's look at the next question now. Hello there, this is another C++ MCQ question, and this is a template question. So this is a little weird one. We are taking integer n as a type here. We are passing 5. What is this? We used to write integer and all other data types here, right? Why we are passing this 5, and what is this all 5 and 5 here? So pause the video and think about it. I think you would have got your answers, so let's check this out. So if we'll compile this, there's no compilation error, running. So the answer is child function. Why it is calling child function? We all know that this virtual keyword is making it call child. If we will remove this like this and we'll compile this again and run this, now this time it is calling base function here. Okay, so that is a virtual part, that is okay. But what is this phi here? Actually C++ not only work with data types, it work with these constant values also. Okay, and this comes very handy when you want to pass some constant while you are declaring the template type. Okay, so sometime what happens, you want to give the size of something, like this array is there, okay, and you want to assign the size as dynamically whenever you are creating that class variable, the object here. Okay, so like this you can pass, like we are passing 5 here, so this array size will be 5. Okay, so this is a very trivial example here of this great facility. Once I will create tutorial for this one, we'll see this in details. Okay, so for now you keep it in mind, like not only data types, we can pass data as well. Okay, so let's look at the next question now. Hello there, this is another C++ MCQ question, and this question is regarding this template instantiation. So pause the video and think about it. I think you would have got your answers by now, so let's check this out. Oh my god, this is a compilation error, and the error is telling that you are assigning some value here, like I is equal to 20, but this I is a constant thing here. You cannot change this. And if you'll see this error message, L value is required as left operand of assignment. So it is telling that this I is not an L value, and L value is a value which takes some value from right side, like this one. Okay, so generally variables are called L value, but as it is looking like variable, but it is not a variable. Okay, as soon as you pass this 5 here, this I will become 5 and you cannot change this. Okay, so if I will remove this statement, this program will work. Let's see that. If we'll compile this again, say it is compiled and running, so the answer is 5 here, because you are setting 5 from here, so this I is getting set as 5. You are printing that. That's it. So we are done here. Let's look at the next question now. Hello there, this is another C++ MCQ question. Actually, this is not a hard question or not a tricky question. If you'll notice something, that is enough. So pause the video, think about it. I think you would have got your answers, so let's check this out. I know lots of people would have missed this, that get x is not the part of this base here. Okay, this show is the part of base, but this get x is not the part of this base. So this is an error. Even though this base pointer is pointing to the derived object, you cannot call
get x on base pointer, because base pointer does not know anything about this get x. Okay, so it doesn't mean that if you are holding some objects in your pointer, you would be able to call that object's functions. Okay, so it is a compile time error. It will compile and check whether this base pointer, which is of type this base here, having this get x function. No, it is not. So it is directly showing the error here. Okay, so we are done here. Let's look at the next question now. Hello there. This is not a very tricky question actually, because we are having very simple code here. And if you got the reason why I created this so easily, don't blame me for that. Okay, it's your intelligence. So pause the video, think about it. I think you are done here. So let's compile this. Oh my god, this is an error, and it's telling that this destructor is in private field. We are not writing anything here like public. That's why it is in private field. Okay, so if you will write public, he will compile this again. There is no issue. And what did I did? Oh, I compiled previous one. So if you will compile this one and now execute it, so the destructor is the answer here. But for this, the compile time error is the answer because you didn't had this public. Okay, I told you don't blame me for this. And if you'll remove this at all like this, then also there is no problem. Okay, but there is no output here. So we are done here. Let's look at the next question now. Hello there. This is another C++ interview question, and this question is a little bit interesting here because we will be learning something new. Okay, so, and yeah, you won't be getting any options here because this is going to be a little lengthy. So try to think here. Pause the video. I think you would have got your answers by now. So let's check this out. What is happening here? If you will compile this and you will run this, so the constructor is being called from 1 to 10 and the destructor is being called from 10 to 1. Okay, so how is it working here? Actually, it is like this. Okay, 0, 1, 2 up to 9 here. So the constructor for array would call like this, like 0th location will be constructed first, then 1, 2, 3, 4, 5, 6, 7, 8 till 9. That's what I showed here, like 1 to 10. Okay, but the destructor is being called in the reverse order, like 9 is destructor is being called first, then 8, then 7, then 6 up to 0 here. So this is also a very important point because someone might think that okay, this is an array here, so the way it was being constructed, it will get destructed in the same way, but it is not like that. And why it's not like that? Let's try to understand it in this way. Like if you will create some variable here like w1 here and another value w2, so this w1 and w2 will get created, but w2 will get destructed before than this w1 because this is coming in the stack of this main function after this w1. So this will get destructed first, then this w1 here. Okay, because it is like we are pushing w1 and then w2, but when we are popping it, then w2 will come first. So in the same way here, we are pushing this 0, 1, 2, 3, 4 all the way to this 9 here on the stack, and when we are going out of this scope, that stack is being called in the reverse order. Okay, that's why the destructor for 9 was called first. Okay, so that was the point here I wanted to show that. Okay, so let's look at the next question now. We're done here. Hello there. This is another C++ MCQ question, and this is not the tricky one. If you can notice something here, so pause the video and think about it. I think you have got your answers by now, so let's check this out. Oh my god, so many errors here. But if you'll see this, why the error is coming, you will notice that this constant keyword is making this error here because you are creating this n as constant and you are going to call this non-constant function on constant object, which is not allowed. Okay, that's it. This is the only error here. So if you'll remove this constant from here like this, compile this again, it will work. Compiling, see it is compiled, and if you'll run this, the answer would be 10 here. Okay, so always remember constant objects can only call the constant functions here. Okay, not the non-constant one. So we are done here. Let's look at the next question now.
So this is another question. Let's look at this question now. This is your base class and you are creating this parameterized variable and you are passing this into this one and you are printing that value. Okay, so there should not be any problem, but still there is this question and I'm going to pause the video. I mean, you're supposed to pause the video. I'm going to count till 5. 1, 2, 3, 4, 5. And maybe you would have got your answer by now. So let's go and check the answer. We will compile this. Oh my god, it is telling you the compile time error. And the reason is you are not creating this base constructor, which is nothing but a copy constructor, as a reference. So it is telling you probably mean this one. Okay, so this reference is only missing in here. So you are getting that error. So if I will create this as a reference, so then there is no issue. We can simply compile this 10. So no problem at all. Just you need to have this reference here. Otherwise, it is a recursive call, which is a problem. Okay, and why it is recursive? You check out my other videos, you will get the answer for that. So why compile time error was there? Because your copy constructor should get as reference. Okay, it should not get as value. Okay, so let's move to the next video now. And yeah, please, if you have any questions, please comment out. I'll be very happy to answer that. And yes, if you haven't subscribed, subscribe my channel so you can get the update for future coming videos. Let's look at the next question now.
Hello there, this is another C++ MCQ question, and this is very easy MCQ question. So pause the video, think about it. I think you would have got your answers by now, so let's check this out. There is no compilation error. Run this, the answer is 1, and then in next line 2 and 1. Okay, so that A is the answer here. And if you don't know the reason why, stay with me, I'll tell you that. So first of all, the x and y both are 1 here, will come to this line. This will get executed first. So plus plus x, this will become 2 here, and that 2 is a non-zero value. That's why we are done here. So this OR need only one condition to be true. So this condition has already succeeded, so it won't execute this at all. That's why x is 2 because this plus plus has executed, but y is 1 because this y is not incremented here. Okay, and why that 1 is coming, this first one, because this whole evaluation is true. Okay, if this is 0 and this is 0, in that case only we'll get 0 here, otherwise in all the cases we'll get 1. Okay, that's why it is 1 here. So if you will write like 0 and 0 like this, and we'll compile this, we'll get some different values here. It is 0 and 1 and 1. So it will come 0 in this situation only, otherwise it won't. Okay, so we are done here. Let's look at the next question now. And this question is not the new question for you. Actually, if you'll notice something here. Okay, so pause the video and think about it. I think you would have come up with the answers. So let's check this out. And this is an error here. Okay, and it is telling that there is no reference to this a variable, which is this one. Actually, it is telling you have just declared it, you have not defined it. So if you are making some variable as static in your class, you have to define it outside that class like this. So the type of this variable is class A. Where is this variable? This is in class B. Scope resolution operator. What value you want to set? Let's suppose you want to set 10 here. Okay, so if you have done this much, this is going to work. Let's check this. Again compile, there is no issue. Run, and the answer is 10 here. Okay, so always remember that if you are making static variable inside your class, you have to define it outside your class. Okay, don't forget that. And if you are creating a class in the header file, don't put that definition in header file. You put that definition in source file, .cpp file, not .h file. Okay, so we're done here. Let's look at the next question now. Hello there, this is another C++ interview question, and this question is about this overloaded new operator and overloaded delete operator here. So whenever you call this new operator on your class, you can overload that so that you will give the memory for that, and the constructor will be called here, and the same for this delete as well. So the internal new will not be called, your user defined, I mean this whatever you have defined here is going to get called. Okay, so pause the video and try to understand what is happening here. I think you would have got your answers by now, so let's check this out. If you will compile this, there is no compilation error, and run. So the new function called constructor called destructor called delete function called. Okay, so what is the order of calling here? Actually, whenever you create a dynamic object like this one here, new operator is being called first. So you need a memory for construction, right? So first you will get the memory, what we are getting from here, and then only you will go for the construction part. That's why the order is like new function is being called here, so the new is written here. That's why this function is being called first whenever you are calling this line here. Okay,
So this is called your memory is created, how much the size of the memory was. So you created using the malloc here, void pointer, and then returning the storage. That storage is coming here only. Now on that storage, the constructor is being called. See here, constructor called, because new operator does two things. First, memory allocation. Second, constructor call. Okay, so memory allocation you can handle like this, and constructor call is automatic. So constructor was called here. In the case of delete, like this one, first your destructor was called, this one, see destructor called, then only delete function was called here. Okay, why? Because if you have some file handling and something which you need to destruct before destroying your memory here, okay, so you'll be destructing first, you will release everything, and then only you will release the memory. Because sometimes what happens, you have file pointers, so you close everything in your destructor, then only you release the memory. Okay, but the construction was different. First you need a memory, then only you will be constructing the object on that. Okay, so this is the order. That's what I wanted to show here. Okay, if you have any doubt, please comment. Otherwise, let's look at the next question. Hello there, this is another C++ MCQ question, and this question is about, we are having this global X and we are making this base data member as a reference of that. Okay, so is it allowed or not? Because this data member is a private data member of this base class here, and if it is referring this X, which is this outside, I mean the global X, so anyone can change this global from the main or anywhere. So in that case, this base X would change. So is this allowed or not? Think about it. I think you would have come up with the answers by now. So let's check this out. We compile it successfully. It means there is no problem in this code, and the answer is 10 here. Okay. So where is the security here? I mean, this X is a private data member of this base class, and someone else, like here, from here you can change it, like X is equal to 20, and if you will print this B again, it will be 10 here, but after changing this X, this will be 20. Okay, so let's check this out. But why it is allowed? It's allowed just because you are doing this. You are the owner of your class here, and you wanted this behavior. Okay, it is not like someone else is coming and making your library work like this. No, you are creating your own library. Let's suppose this is a library and you want this facility, so you did this, not somebody else. But this is generally not a good practice, because we can access this global in thread where it will be a race condition, so that we'll not discuss here. But the point is, yes, this is possible. Okay, so we are done here. Let's look at the next question now. Hello there, this is another C++ MCQ question, and this question is not having any problem. Okay, just you note down the order of print statement here. Okay, so if we are constructing P here and passing this P to this B, which is of this Q type, then what would be the print statement sequence here? Okay, so pause the video, think about it. I think you got the answer, so let's check this out. There's no compilation error, and the answer is P is constructor, P is constructor, P is assignment operator, and the Q is assignment operator. So I'll take you through whole execution process here. So let's see this P here first. So the P will get constructed with this construction here. Okay, so P's constructor is called, that's why this first P constructor was called here. Another P constructor is this P constructor. Okay, why? Because you are creating this Q object B and you're passing this P as a parameter. So for that, this constructor would get called here, and this is a reference, so there is no copy, and you will go inside this. So you are assigning QP, which is this P, with this P, which is this P. Okay, that's why you need to construct this P first. That's why this second P constructor was called here. After that, you assigned it from here to here. That's why this assignment was called. See this assignment operator, and once everything is done, you are lastly printing this Q constructor. Okay, so this was the order of evaluation and execution here. Okay, so we are done here. Let's look at the next question now. Hello there, this is another C++ interview question, and this question is a follow-up question. So if you have not watched my previous video, which is 135, this question, please watch this, then only you will be able to understand and the significance of this 136 number MCQ question. And the difference between these two is here we were initializing this P here like this inside this constructor without using the initializer list, okay, and here I'll be using the initializer list. That's the only difference here, okay, and we'll see what's the benefit of using this initializer list here, okay. So you think about it, pause the video. I think you would have got your answers by now, so let's check this out. So we'll keep the previous questions output as it is. We'll compile our new program here, okay. So this is 136.cpp here. We'll compile this, no problem, and the answer is P constructor, copy constructor, and the Q constructor. So what is missing here is, instead of these two, we are only having this, a copy constructor, this one. Rest is same. This first is first here and the last is last here. But these two statements became one statement. It means you are calling only one function here, whereas you was calling two time functions here. So let's see what is happening here actually. So firstly, you created this P, that's why this P constructor was called, so no problem in this first statement. Next statement is you're passing this P into this B. So this is nothing but this call, and we are using this initializer list. So it is just using a copy constructor and copying the content of P, I mean this P into this P, okay, I mean this P into this P, and constructing this P at the same time. Before, what it was doing, it was creating this P first and then initializing this P into this P. Result of this construction is this one, and the result of this assignment is this one, okay. So you can see the same thing is happening, but here we are calling two time functions, but in this case we are calling only one time, okay, this copy constructor, and this copy constructor is creating memory for this P and copying the data. So this copy constructor is doing two things altogether, okay. That's why we should always use initializer list wherever we can, okay. So I think I'm done here. Let's look at the next question now.
Hello friends, welcome to another MCQ question, and this question is going to be a little tricky here because I have used this operator overloading case. So if you don't know what is operator overloading in C++, just go and study that and check out this video after that, okay. So if you know, you can just go ahead. So this is your B1. This is a repetitive code what you would have seen in previous videos. So I'm calling this C out with B2. So this is an operator overloading situation here. So let's see, you can find the error in this, okay. So I'm going to count till 5, pause the video and try to understand the problem here. 1 2 3 4 5. So I think you will have got your answer by now, or maybe not. So let's go and compile this code. This is 15, right? Yeah, okay. So it is a compile time error, so answer is C here, okay. Why it is telling you the compile time error? So we'll just try to understand that. It is telling you cannot bind O stream, which also known as basic O stream with characters with L value, to this one. So this is very standard error. The only problem here is this cannot be the member of this class, okay, because no, I won't explain this in this video. To get the answer of this video, you have to watch just next video of this video, okay. So for now, just we'll keep the error as compile time error, because if I will mess up all these things, it will be very hard to understand all these things, okay. So let's look at the next video to understand why it was failing, okay. So I'll see you in the next video. Hello friends, this is a follow-up video of previous one. So if you have not watched the previous video, please go and watch the previous video. And if you have watched the previous video, you will notice that only this friend keyword is extra in this video, okay. So I will just compile this code so that we can just see it is working perfect. Yeah, so after inserting friend only, it started working. Why it is like that? There is two reasons. If you are calling this as friend, it means this doesn't belong to your class, okay. This is outsider, okay. So there are two ways of creating friend function. Either you declare a friend function here and define outside, okay. So I have used it this way, but I will just simply create the other way also, so that it will be very easier for us to understand the topic here, okay. So now let's compile this, and that's it. This is your friend function, and this is the definition of that. So generally we keep like this. But why do we need this friend? So there are two reasons. First is you want this function, this is a function, okay, operator, this is a function. You want this function not to be included as the base internal member function. First reason is that. And second reason is you are keeping this function as a friend just because you want to get the private part of your base. Okay, so that is the second reason. And why we don't want this part of your class is just because when we call some functions, like we know this base is being called here like this, then what is happening? Actually you're calling this constructor like this one. Okay, in this case you're calling this constructor. Okay, but how you're calling, when you're writing this program like this, your compiler will change this program into something like this. This base will have address of b1 comma 10. Okay, I have explained this whole thing in the previous video, that how you get this pointer inside your member function. We all know that we get something called this pointer in our member function, but how do we get that? So this is the way we get it. Okay, this line will get erased, and instead of this line, compiler will generate this line, and address of b1 is going at the first parameter internally. Okay, and this is also supposed to get changed here. So your compiler will change it like this. You will have something called base, and this base address this and integer x, and rest of the code will be similar like this one. Okay, but internally it will change, okay, here, but and this one is also this x. So this is how your compiler will change this line into this line. That is the only reason we always get this pointer inside our class. Okay, we all know we get this pointer, but we generally don't know from where it is coming. So compiler is changing our code, that's why we are getting this pointer like this. Okay, so all the classes and all the functions are always changed if it is not a static function, because you don't get static like this. Static is a straightforward calling, because that is not the part of your class exactly. Okay, you don't need this pointer in that static. Okay, because you don't call static functions with your objects. So why I'm explaining all these things to you? The only reason is your class is getting changed because of this one. Okay, and it is changing it itself. So don't you think if you would have not written this function here, then what your class will do? Your class will try to change this also, like it will create base pointer this comma and this one, and let's suppose I'm not having this one, or just keep it that way. Okay, so your class will try to do it like this, at least append this here. Okay, and when you're calling this, you will be calling something like this, operator less than. So as here you was calling the base with the help of b1, so that you was passing the address of b1, here you will pass cout. Okay, because this operator is attached to the left side of your operator, whatever is the left side. Okay, so left side is cout, which is part of your output stream. That's why you want this to be as output stream. Okay, that's why we write this o as stream at first parameter. Okay, that's why we overload our less than operator in this way. Okay, and second parameter is always your object, what you want to print. Okay, so that is the reason internally. So when you will write like this, your compiler will change it something like this, cout comma b2. Okay, so this is going to get called like this, and this will look for this function. Okay, so this is your function name here, and it is overloaded. And yeah, one more thing, this function is already present inside your IO stream. Okay, or output stream. You are nothing but overloading it. Okay, so you are passing your own parameter, which is nothing but overloading your existing operator less than inside your IO stream. Okay, in order to show you that whatever I'm telling is correct, I will overload integer. Okay, so it will be very clear for you to understand in that case. Let's suppose I am overloading here for integer, and this is a fair overload. I can show you with this example. We all know we can do it like this. Okay, if you are going to print 10, it is going to print. Okay, but I have given this function explicitly, and this function is there inside your IO stream also, so it will tell you that you cannot overload this and there has to be some ambiguity. So let's check that. I'll compile this code and it is telling you compile time error, but there is this we have to find somewhere. Yeah, see, it is telling you ambiguous overload for integer. Okay, that means the same function is there inside this IO stream. Okay, that is the only reason we all happily print this integer value, because this kind of operator, overloaded operator, exists inside that. Okay, and what doesn't exist? This one doesn't exist. Okay, this is another overload of my own type, which is base. So this is whole thing. I think maybe I cleared the doubt why we keep friend here, and what is the reason of keeping it like this, like OS stream and all that. We always see that we need to pass first parameter OS stream. So what is the reason behind that? This is the answer for that. Okay, and please tell me if you have any doubt for this. Okay, I'll be very happy to explain all these things. Okay, so let's check out the next video.
Hello there, this is another C MCQ question, and this question is not a very tricky question. So if you know that we can write it like this or not, you got this question. Okay, so the point is, if you will replace this call X with this statement, then only this code will compile successfully or not. Okay, so long story short, if you want to access this X inside this, we all know that we can use it like this. Okay, but can we use it like this as well? So that's the point here. So pause the video and try to think about it. So I think you got the answer, so let's check this out. There is no compilation error and it will run this. The answer is 40. So yes, you can use this scope resolution operator in order to access this data member. So it is not like you can only use this style, you can use that also. Okay, so let's look at the next question now. Welcome back. This is another question. We have not talked about this, what I'm going to talk right now. Okay, so let's try what would be the output of this one. And I know if you will guess it, don't run away, I have something to tell. Okay, actually there is no need of these two lines. Yeah, now you guess what would be the output of this one. So I think you would have got your answers, so let's check this out. This is GC++. There is an error. Why? It is telling that no matching function for call to print and print. It means if you are creating array of objects, see, you are creating array of objects because you are having this print as type. Okay, so in that case you must have one default constructor like this, otherwise this is not going to compile. See, after writing this one, let's save this and compile it again. It will compile without any problem. See, it compiled. Okay, see, so why it is like that? So you guys might be thinking that I'm not passing any parameters, so that's why it is not calling this print constructor. Okay, but no guys, if you are creating an array of objects like this, you don't have option to call this constructor directly. Okay, you have an option like this. You can do this without any problem, like 1, 2, 3. Then there won't be any problem. See, if I will compile this, it will compile. Okay, so this time it is calling this constructor. Okay, let's print that. So I'll just simply remove this line here, then we will understand it better. So for this it should be default and parameterize, right? Okay, so if we will compile this, we'll get to know what is being called and what. Okay, so let's run this. So 2 times default is being called here because we are not calling the parameterized one and we don't have any option. Okay, you cannot write like this here and pass like 1 or something, so all objects will be called with this one parameter. No, there is no option like this. One option is you can initialize what you want, like 1 and 2. So in this situation, it will call the parameterized one. See, it is calling parameterized constructor. Okay. So what we learned from this video, you don't have any option when you are creating an array of objects like this to call your parameterized constructors. Okay. You will have to call default constructor, because that is the only constructor available if you are not going for the initialization as well. Okay. But if you are creating some simple object like this, everyone knows that you have the facility to call your parameterized constructor. So this will call parameterized constructor here, okay? But you cannot do that with this array here. There is no such thing like this, passing some value here, okay? So I think I'm done here. And yes, if you think you learned something, don't forget to hit the like button. And if you haven't subscribed yet, go for it for the daily updates like this.
Hello friends, welcome to another C++ MCQ question, and this question is something like this. There is a base class, there is a child class, and yeah, one more thing I wanted to tell, that I'm using this child, and here it should be a parent, like yeah, generally what naming convention we use, but doesn't matter, okay? And if I'm using base here, then I should use derived here, but it's just the naming convention, okay? So don't get confused with that thing. I know you won't get confused, but still I'm just telling that. So this is child class. You have inherited base class with public and all that, and everything is just looking fine. So just try to understand what is the output for this. I'll count till 5. 1, 2, 3, 4, 5. So I think you would have paused your video and come up with the answers by now. So let's go ahead and compile this program. So the program name is 16. That's it. Okay, we got compile time error here, and that error is that class child does not have any field name underscore x. Okay, so that we can just directly see here. This x underscore x is coming from here. Okay, so generally what people think, that everything is coming into here, so this x is also coming from here to here, and then I will directly initialize that x from just this x what is coming from here. Okay, but it doesn't work like that. In order to initialize this x, you have to call base constructor explicitly. Okay, so I'll just show you the way how we do that. So in order to call your base, you have to do like this. Now this is the perfect code. There is no error. We can just compile this again. Yeah, see, it compiled. And if you want to run this, then output would be base initialized x, child initialized x and y. Okay, so the answer for this question would be compile time error. Okay, and why? Because you have to always initialize your parent member by calling their constructor inside your constructors while you are calling your constructor. Okay, so and this is the way. Let's suppose there is another constructor, let's suppose there is another class, let's suppose there is another parent class, then you have to call that parent class constructor also in order to initialize any data member of that class. Okay, so what you are doing here is you're just simply calling this base here, this x is going here, and you are telling to the base that okay, now initialize this x with whatever the value I'm sending from here. Okay, so this is how it works. And in short, if you want to initialize your parent members, you have to call their respective constructors, okay, from your constructors. That's it. Let's look at the next question now. So let's look at this question now. This is your base class. Again, this is a child class, and this question is little bit similar to your previous question. Okay, but there is something in this you need to find that. Okay, so I'll count till 5. You pause the video and try to understand that. 1, 2, 3, 4, 5. Okay guys, I think you have come with your answers, or maybe not. So let's go ahead and compile this. So in order to compile this one, this question is 17, I guess. Yeah. So we'll compile this. Again there is an error. So what is this error now? This time it is telling no matching function for call to child, this one. So the error lies in this line. Okay, and this is nothing but here this first line. Why? Because there is no constructor for this one. This is a default call. Okay, this is parameterized call, this is default call, and in order to create a default object, okay, you need to have a default constructor. So if I will write something like this, just for namesake, this is going to work. Okay, we can just compile this. Oh, what am I missing here? Okay, yeah. And in order to make that happen, I have to call this base constructor, and here also I have to have this constructor. Yeah. So now if I will compile, it will get compiled. See. So if you have given any constructor, suppose parameterized constructor, then you have to give a default constructor. Okay, this is the requirement, and you saw that you didn't had this one and this one. So in that case, your code was not compiling. We all saw that. Okay, just because you have created a parameterized constructor, this one, and it is a rule in C++ that if you have given any constructor, then it's your job to give rest of the constructors. Just think like that. Okay, I won't go much into that, but just think like that. Got it? To tell precisely what is happening here, it's like if you will give parameterized constructor, you have to give default constructors also. Okay, so I have just given these default constructors here, and your code is working fine. Okay, we can compile this once again, and we'll try to run this. And again, the answer is base initialize x and child initialize x and y. Okay, I know child is not initializing x here, but just passing and x is being initialized here, but still I'm telling that x is initialized here just because you are getting x here. Okay, so don't get confused that what I'm writing here is not matching with what is happening. It's just a message. It doesn't matter much. So let's look at the next question now. So this is the next question here. This is again looking like the same question what we had before, but I have only changed the placement here. Like this has come here and this has come here. So I have just swapped the places of these two. Okay, and I have removed that default constructor call. So what do you think? What should be the answer for this now? Before this base was written here. So just think. I'll pause the video. 1, 2, 3, 4, 5. And I think you would have come up with your answers now. So let's go ahead and compile this one. The question number is 18 here. Yeah, it compiled successfully. And if you will run it, what is happening here? Yeah, if you'll run this, it will tell you base initialize x and child initialize x and y. Okay, so this one is the answer here. It doesn't matter what is the positioning of your base constructor call. Okay, don't think that it should be in the first place and rest of the initialization should happen in the next coming places. No, it is not required. Like you need to do something like that. Okay, you can change this because there is no dependency actually, so you can change it. And dependency means if you are initializing this one and you might be needing this part in here, then there comes the dependency. Okay, so that will come and check later how this dependency work and what is the order of calling this parameter initializations. Okay, and what is the order of this parameter initialization, we'll come and see later. Okay, for now this is your answer. There is no need to keep this one as first. Okay, so I just wanted to clear that out. So let's move to the next question now. Hello friends, welcome to this video, and this is a follow-up video of the previous one. Okay, and here I have included this using one add. Okay, so before we were getting answer like 11 and 11, and this time we'll get this 11 and 10.6, which is expected. So let's go and compile this. G++. Question is this one, and the answer is C, 11 and 10.6. I should have just done it simple. (11 and 10.6). So what is this using one add? Whenever you inherit something, then the scope of that is not getting inherited. So this add is in different scope than this one. So that's why it is not overloaded. That's why this overloading was not working in case of 2. What generally people think, if I have inherited 1 from here to here, then this function is also coming and getting placed here inside B. Okay, that is true, but the scope is different. Okay, and if you want to tell the compiler that I want this add here with the same scope, okay, I want to keep this function scope here, okay, not here, then in that case you are telling that this is the way of telling that. I mean, yeah, you are telling to the compiler that I want the similar scope. That's why you are writing this one, and that's why we have achieved that, which we didn't achieve in the previous video. So if you have any doubt, please comment out. Otherwise, let's move to the next video now. Hello guys, this is another MCQ question. Try to understand this. This is new than all the previous videos. So just try to understand. This is very simple, I guess. You will crack it. I'll count till 5. You pause the video. 1, 2, 3, 4, 5. So I think you have solved the questions. So just compile this blah. Oh my god, what it is telling? It's a compile time error. I mean, yeah, this D is the answer for this one. And the problem in this is you have this static X here. Actually, this static X is not the problem, but this is just a declaration part. In order to do something like initialization and use that, you need to have the definition where you will initialize this. This is just a declaration. So in order to initialize that, you must have something written like this, underscore X. Okay, this one. If this line is not there, your whole code will not work. So let's check this out. If you will compile this, successfully compiled. Now run this, it will tell you 10. So most of the people would have got this 10. I know that. So I think I made my point here. This static is nothing but the declaration part. Okay. You have not given any memory for this one. So until unless you don't have memory for something, you cannot initialize, right? Because you don't have that exactly. You just have the entry in your table. Sorry, I will not explain that table because it's symbol table and all that. But just for now, you try to understand this. Your compiler just kind of know that something called underscore X is there and its type is integer. But the location, the memory is not provided to this X. And how it will get provided? You have to write something like this. Okay? It is nothing but telling to the compiler that there is an integer variable inside base and its name is X. Okay? So this is how you have to do if you are creating static data member inside classes. Okay, so this is the required case. So I think I made my point. If you have any doubt or questions or want to discuss something, please comment out. I will see you in the next video. So this is your next question. Exactly, yeah, I can see that you will be telling like this is again the same looking question, but it is not. Okay, there are lots of corner cases I wanted to clear. That's why I have started this MCQ questions. So just try to understand what is happening here. And if you have watched my previous videos and understood that, you will be easily cracking this MCQ here. Okay, so I'll be pausing this video. 1, 2, 3, 4, 5. So I think you would have come up with your answers by now. So let's just compile this code and try to see what is the output for this one. And this one is 19, I guess. Yeah. Oh my god, it is again the error here. I can just show you this line, and you know what, we have already covered this in the previous videos. Okay, what is this? I just wanted to hide this happening here because of people do like that. Okay, while you are going and giving some MCQ questions, they will always try to hide their problem. So I hide my problem here by putting this one in between these two. Okay, and the problem here is you don't have constructor for this one. This is again a default call and you don't have your default constructor here. If you have watched my previous video, you will directly get to know that what I'm talking about here. Okay, so if you have something like this, and here also you need to have some base. Okay, now this code is perfect, so we can just see this. We will compile this code. What is this again? Yeah, see, it compiled, and now if I will run this, it will give me the same output as this one. Okay, so let's move to the next question. And yeah, please, if you have any doubt or something you want to tell, you can just please comment out. Okay, I'll see you in the next video. Hi, so this is another question, and in order to understand this question, you should be knowing what would be the size of some empty class. Okay, I'll count till 5. You pause the video. 1, 2, 3, 4, 5. Let's check this. This is 21. It compiled successfully, so there is no compile error. Okay, and let's suppose if we will run this, enter is, and the answer is 1. So the answer is A. Don't think that always answer would be A or something. Okay, why it is giving you 1? It is because the creator of C++ thought you have one empty class and you create an object of that class, let's suppose like this, B1, then B2. Then in order to distinguish between these two, you at least need 1 byte. Okay, so if you will check this, like address of B1 is equal to address of B2 will never be same. Okay, it is not going to be same ever in C++, but in C the answer would be 0. So first we will talk about C++ here. So the creator of C++ thought, okay, if I will give the 0 size, then maybe this B1's address would be equal to B2 address, and let's suppose if I am creating some another object, or just leave about the object, we can just simply create one array of, let's suppose array of 10 or 100. Okay, so 100 objects will be there, and in loop, let's suppose you are doing something like this. After doing it like this, you are allowed to do this, okay, +1, and you can just assign this into some base pointer here. Okay, this is allowed. You are just taking the address of ARR, which is this one, which is pointing to the 0th location, and now you are telling you just point to the first location by incrementing it by 1. So if you are going to increment it, it will get incremented by the size of base here. Okay, and size of base is 0, then in that situation how it will increment? So that is the problem here. And if you still didn't understand, I will create one integer array. Let's suppose integer array int array of 100 size, and now we all know we can do something like this: integer I is equal to 0, I less than 100, I plus plus, and then cout integer array plus I. Okay, so this statement is exactly same as this one, int ARR of I. Okay, so here you are just telling to the compiler that there is a base address. This integer array is showing here the base address of this array. Okay, and you are getting the offset by just adding this one. So in first loop you will add 0, that means nothing, so you will be outputting the first element, and next loop you will give 1, so this time you will get incremented by 4 bytes. Okay, and by 4 bytes I mean you are having this 0 to 99 here. So this 0 to 99 are the blocks here, because you have 100 blocks of integers. But if you will look at the raw memory here, you will be having something like 0 to 99 and altogether multiplied by 4. Okay, why 4? Because integer size is 4. I am having 32 bits, so I'll just consider this as 4. Okay, so these many bytes are there. Okay, so in order to simplify this, I will just write it like this: 3999. So these many bytes are there in this array. Okay, and if you are telling cout this one, okay, and this is the base address which is pointing to the 0th location always, and you are giving the offset here 0, in that situation you are again reaching at the same position here. Now you want to output this. Okay, so you have from 0 to 399, then how your compiler output only integer part? Why it is not giving all the output? Just because its type is integer here, and integer means 4 byte, so it will take initial 4 bytes like this. Okay, it will take this one, I mean these 4 bytes, and whatever the values are there in those bytes are always in 0 and 1 form, and compiler will just simply convert that form into the decimal format because it is an integer here, and will just print that. And this was the situation here because of this 0 here, because this I was 0 in first place. Let's suppose this I became 1 here. In that case the integer array will get incremented by 4 bytes. Okay, you just remember this, we always increment the whole byte array with size of its type, and size is integer, I mean type is integer, so the size would be 4. So next time if you will do 1, you will reach to 4 here. So now this 4 is your base here, and again from 4 it will take 5, 6, 7. Okay, so these many bytes will be taken here, and these bytes will have zeros and ones in that, and OS will take those bytes, convert into the decimal and print it. So this is how this whole thing work. Okay, I don't know what I was explaining and what I started explaining, I don't know. So I think I made my point. I just got lost here. I don't know what I'm doing now. Yeah, I found why I explained whole these things to you. And let's suppose this time you was incrementing this integer, right? Let's suppose this is your this array, base array. Okay, now in order to increment this base array, you must have its size, but its size is 0. This base size is 0. If it is not 1, then it is 0. Okay, I mean right now it is 1, but if suppose it is 0, then what is the problem? I'm going to explain that only. I'm trying to explain that only. So this base is having 0. In that case, it will again come to the same location. This 0th location. And if you will do 1, it will again come to the same location. 2, same location. 3, same location. Because it doesn't have any size, then how this increment will happen? Here in integer case, it was happening just because this integer size is 4. It is fixed. So our compiler was skipping 4 bytes and going like that. Okay, but in our base class there is no size of this base, no. So how you will jump like this? So that was the problem. That's why they had to keep its size at least 1. Okay, so I think I made my point, and I know lots of doubts will be there. So if you have any doubt, please comment out. So let's look at the next video now. So this is your next question. This is similar to the previous one. We have this empty base here. Don't think that you have constructor so that it is not an empty. It is empty even if it is having functions also. Okay, it is not empty if it is having any data member like integer x or character y or something like that. Okay, in that case it is not empty. Otherwise it is empty whatever is there in that. Okay, and this empty you are inheriting into this child one. This child is having integer x, so in that case this child will inherit this property into this one, and I'm just printing the size of base and the size of child. So in order to clear one doubt of yours, so let's see, maybe you already know the answer. So let's count till 5 and you just pause the video. 1 2 3 4 5. I think you would have paused your video by now. So let's look at the output for this one. This is 22, right? 22, it compiled successfully, so it means compile error is not there at least. Now we will compile. Yeah, and the answer is 1 and 4. So now see here why it is like that. If base size is 1 and child size is 4, this child is having this integer x and you are inheriting base, then in that situation that one size should also come here and your child should become 5. Lots of people would have think like that, but it is not like that, because if it is empty class, then in that case this class size will always be 1. But if you are inheriting this class into some another class, then empty base class optimization happens, and in that case your child will not have that extra byte what you was using for this one. Okay, that's why you are having this output 1 and 4. This 4 is there just because your integer is of 4 byte. And just sake of curiosity, I can just simply do like this. Now also its size is 1 byte. Okay, and if this is inherited here, this one would become what? 5 byte, right? No, my friend, we can see the output here. It will compile successfully, and I'm telling you, this is not going to be 5 this time, because something called structural padding will kick in and this will become 8. Okay, so don't be shocked so much. Yeah, see, 1 and 8. So what is structural padding? I have another videos for that. Please search in my playlist, you will get it. Or if somebody want, I will give the link in the comment section, so don't worry about that. So this time also you can see the base size is 1 only here also, See, 1, 1. But this child has increased by 4. It should have been increased by 1 only. If you want to see 5 here, I can write something like this. Pragma pack 1. And this is the way to do that. Compile, run. See. Now it is 1 and 5. So what I am telling to the compiler is don't use padding here. And that padding is really very big topic. I cannot include that in this MCQ section here because these MCQs I have just planned to end it before 2 and 3 minutes. Okay, not exceeding more than that. So if you want to see what is structural padding, you just check out my other playlist. So I'll see you in the next video. Hello guys, this is your next question of MCQ. Try to find the answer for this one. Okay, is there any error or something? This is very simple. I know. I'll count till 5. Find the problem, or if there is no problem, tell me the answer. 1, 2, 3, 4, 5. Oh, it was very fast. So let's look at the answer. Yoo-hoo, the answer is this one, this one, and this one, and so the answer would be A here. Oh my god, I again kept answer in A. No problem. This was very simple, I know. So let's look at the next question. That is not going to be simple. Welcome back. This is your next question. And this is again the simple question. Don't get confused so much. But I know most of the people will not be able to find the answer for this correct. Okay, I'm sure. So I'll pause the video. I mean, you are supposed to pause the video. I'll count till 5. 1, 2, 3, 4, 5. So guys, I think you would have come up with your answers by now. Let's compile this. This one is 24. Compiling. Yeah, at least compile time error is not there. Now run this. A is the answer here. Okay, but why A? This base is getting created, then this base is okay. This base is getting printed here. After that, this base is calling, so this parameterized base will get called here, then this one should be called. But why there is a destructor in between these two? I wanted to show this only, that if you create a temporary object, this is a temporary object, okay, because you are not initializing it anywhere. So whenever temporary gets created, at the same line it gets destructed also. Okay, so here it got constructed and here only it will get destructed also. Okay, so if you want to see answer this one, you have to watch my next video. Okay, so what is happening here, I'll just explain, then you go for next video. So here you are constructing a base here, it is getting called this one, and base is getting called here, and this is printing base. And as I said, the temporary objects get destructed in the same line. The destructor is also called here. Okay, so this destructor get called, so that's why you are seeing this destructor here. After that, this is over, then this is also a temporary, because you are not, no, I will not tell that, otherwise the secret will get revealed. Okay, this is also temporary. Okay, in that situation you will call this one, and this temporary is a parameterized temporary base call. Okay, so in that situation you will call this one, so that is okay, we are calling this one, and here you won't be able to see much. Okay, so in order to show you that, I will just do something like this. Okay, and now we will compile this, run this. Again, see, base created, destructed, created, destructed, created, destructed. So whenever you create any temporary object, it get created and destructed at the same place. It doesn't wait for scope thing, because we know this destructor should have been called when you are hitting this line. Okay, this is what we all have studied, but it doesn't happen in case of temporary objects. Okay, so let's look at the next video to understand why it was happening and how to avoid that. So this is your next question, and here if you notice, I'm assigning this one to some object here. Okay, so now if you don't want your destructor to be called at the same time, you have to create a permanent object. Okay, before you was just simply writing like this, okay, this one only, and here it was just this one. So you are not assigning the created memory to some real-time object so that its scope can be extended to this whole scope. Okay, you was not doing like that. I mean, if you want your base object not get destructed at the same time, you have to assign that memory to some object. Okay, now this object is having full scope of this one. Okay, now when the program control goes out of this boundary from this start to this end, when it will go out of here, these two will get distracted. So now we will just see that. I will try to compile this. This is 15, right? And run. See, base constructed, this one also constructed. Before, this destructor was coming in between these two here. Okay, you can see here. This is your previous program's output. Now what is happening? You are creating a base. You are assigning into B1. Now this B1 is holding that memory, and this B1 will not get destroyed until unless you go out of this scope. Okay, now it comes to the scope, or in order to explain you much better, your temporary objects are having scope of their line only. Okay, and these type of objects are having scope of where they were created, like from here to here. So this is the short answer for that. So I think I have explained it, and still if you have doubt, please ask me. I'll be very happy to explain in the comments. I don't have any problem in that.
Hello friends, this is another MCQ question, and I'm not able to show you the full output here. I mean the full options. So I will just grab this one, try to paste it somewhere else. So this, I have opened extra pan here for you. Here we can keep this. Okay, so let's look at the question now. Pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have come up with your answer now. So let's look at the answer for this. This is 26, right? 26, and there is no compiler, so at least compiler is not there. And there is this base child base destructor, base child base destructor. Okay, so I have chosen this question to demonstrate that what is the way of constructor calling. Okay, what is the sequence of constructor call here? So we'll see the first case here first. So in order to complete this one, your constructor should be called, and don't forget this is nothing but your temporary object calling here. Okay, that's why destructor is also called at the same time. So if you have attended my previous videos, you will understand that little better. Okay, now let's take the first case here. Your child is going to get created. This is default, so we will end up calling this one. And now first answer is, the first print is base. So when you call this one, it won't call itself first time. Okay, first it will go and call its base. Okay, this one. So this base will be called here. So this base is this one. That's why this base is coming here. We can see in the output. Okay, this base is coming first. After the base is created, child will create itself. It means after the construction of whole parent things, let's suppose there is another hierarchy, like this base is also inherited something from that. So in that situation, you should call that also, like here you can say some class or something like some class. In that, this some class will be called first. After that you will come from there, and then only you will construct this base, and then you will come back here, then only you will go for child construction. So it works like that. If you have parent, you feed your parent first, okay, or you construct your parent first, then only you construct yourself. Okay, because without parents you doesn't exist, right? So if you want to understand it like this, you can understand like without parent you don't exist. So first parents will get created, then only you will get created. Okay, so that's why this base is getting created first, and after that you are coming here and you are creating yourself. And why this destructor is happening? Just because this is a temporary object. I didn't put this child destructor, I should have kept it. I just forgot that, so we can just keep it now. What should be the child? Okay, child destructor, and done. Let's recompile and check the output. See, this base is created. As I told, first base will get created, then child get created. But if you want to destruct this object,
because this is temporary, so this is going to be get destructed in this line only. So when you are going to destruct it, first you will call your destructor, then only the base destructor will call. So in case of destruction, the order is reversed. Okay, you can see here, when you created child, you created base first, then you created yourself. But when you are going to destruct this child, you will call destructor of the child first, then only you will call the destructor of the base. Okay, so this is the way destructor get called in the inheritance hierarchy. Okay, so we are done here. If you have any doubt, please comment out. I'll see you in the next video.
Hello friends, this is Rupesh and I'm watching CPP video series on C++ MCQ question, and in this video we'll be learning about this friend keyword. Okay, so let's understand this program first. So this is the base class. You have this integer b inside that, and we are deriving this base inside this derived class. We are having another member named d, and here is the syntax where we are telling that this function, which is this one, is my friend. Okay, so inside this function we are just taking this class object d and assigning 10 and 20 inside b and d. Okay, so as this friend keyword says that this function is my friend, so this function can access private, protected and public data member of this derived class. We can access and simply just print that. And wait a minute, did you find some problem in this code? If you spotted that, comment out. So let's pause the video and try to think about it. 1, 2, 3, 4, 5. I think you would have got your answers, so let's compile this. Okay, this is a compile time error. Actually, the problem is we have this friend function, and friend function can access only what derived can access. Okay, so there is a class which is derived class, and it says that okay, this function is my friend. So this friend function, which is this one, can only access what this derived can access, and derived cannot access this integer base because it is declared private inside base. Okay, so that's why we are getting this error saying that b is a private, whereas this dot d can be accessed because this dot d is the member of derived class. It doesn't matter your derived class member is private, protected or public. If you have made some friend, they can directly access that. Okay, so how to deal with this problem? There is a keyword called protected. If we will use that keyword, now this friend function can access b. Why? Because this derived can access b. That's the only rule. Whatever this class can access, your friend function can access that. And now as you have made this protected b, b is protected, you can access that b inside this one. This is the rule of protected data members, right? This cannot be accessed from outside world, but it can be accessed in the derived classes where you are deriving the base class. So let's compile this and check. See, 10 and 20. So there is no problem in this code now. And as I was telling, if we want to access this data member from outside class, we won't be able to do that. And let's check that. Object.b. Just simply print that. Okay, so if you will compile this, you will get the error saying that it is protected. Okay, and lastly, if you will make it public, this is accessible in all the cases. Let's see that. See, now it is 10, 20 and some garbage value here because we are printing b without initializing, so we are encountered with some garbage value. So that's it. Please comment how did you feel about this video, and like and subscribe for more videos like this. Bye bye. I'll see you in the next video.
Hi friends, so let's look at the next question. This one is one base class is there. You are having data member here, constructor and some print function here, and I'm just assigning this b with 10 and I'm printing that and everything is okay. Okay, so now I'm going to count till 5. You pause the video. 1, 2, 3, 4, 5. So I think you would have done your homework. So I will just compile this. This is 1.cpp. Some of the people might think like, why I'm having jumbled numbers, but that is not the concern here. Yeah, so the answer is compile time error. Compile time error just because your constructors are in private section of your class. It should not be in private section if you want to create your objects like this. Okay? You cannot do that. This base will call this constructor and which is in private section. Okay? So yeah, there is a compile time error. If this would have been in public section like this, I'm going to put now public here. Here now public. If you will compile now, it will compile successfully and the expected answer would be 10. Okay? So now let's move to the next video. Hi, this is your next question. Try to understand this. I'll pause the video. I mean, you are supposed to pause the video. I'll count till 5. 1, 2, 3, 4, 5. And I think you would have got your answer by now. So answer for this is, it is a compile time error. It is telling you that you are going to initialize this x, which is a constant here. Okay? You cannot do like this. You cannot initialize a constant inside your constructor like this. There is a way when you can initialize the constant in your constructor, but in order to see that, you have to watch my another video. Okay, so for this video, the answer is compile time error. You cannot initialize this 10 to this x, which is constant. Okay, so this is the answer. This is a compile time error. So let's look at the next video to see how you can initialize a constant from your constructor like this. Okay, so let's look at my next question. Hi, this is another question, but looking exactly the same. I'll tell you where the difference is. Okay, this is how you are initializing and this is the reference of integer. Okay, this is reference variable and you're going to initialize that with 10 here. Okay, and this is the whole code, exactly looking like the same video you saw just before that. Okay, so try to think whether it is allowed or not. I'll count till 5, pause the video. 1, 2, 3, 4, 5. I think you would have got your answer by now. Let's look at the answer for this one. So this question is 30. There is an error, guys. It is telling uninitialized reference member integer reference. Okay, and you cannot initialize it like this. Okay, in order to initialize this, you need to initialize in some manner so that you can initialize it, and for that I think you should watch my next video. Okay, so for this video, this is an error. You cannot pass this 10 here, you receive it 10 here, and you are assigning that 10 to this x, which is of reference type. Okay, this is possible. For that you need to watch my next video. Okay, so I'll see you in the next video. Hello friends, welcome back. So in this explicit case, what will happen? Is it going to assign this 10 into this? I don't think so. Let's just compile this. So this one is 40. I'll just compile this one, and the error is this: you cannot assign 10 into this now because this constructor is declared as explicit. If this explicit is not there, as the previous question was not having this explicit keyword, and now if I will compile this, it will compile, and if I will run this, it is going to give you the same output. But we are here to learn the use of explicit keyword here. Okay, so explicit means you are creating this constructor explicit, like you have to call this explicitly. You cannot just call implicitly. This kind of calling is implicit call. Compiler understand by itself that okay, I am assigning one parameter, okay, into base, and does base have one parameter constructor and that parameter's type is integer? Yes, then I will just simply call that. Okay, but if you don't want that behavior, because that behavior is a misleading behavior, because sometimes what happens, you might create some function, like suppose you have created some function here, and here you want a base b. Okay, inside this function you might be doing something, but if you want to call this function, now you have two options. Either you will be calling with some object or you will be calling with some number here. These two things are possible. Okay, and this is a misleading thing whether you should be allowing this kind of things or not. Okay, so this is the reason actually we use explicit here. So I think I explained it. Let's look at the next video now. Hello friends, this is a revisit question. Okay, there is a guy whose name is Abhishek Yadav, I guess. He asked me this question that he is confused whether we should include default constructor or not. I mean, in what scenarios we should go for default constructor, and in what scenarios you can rely on the compiler given default constructor. Okay, so this video is for that purpose only. So let's go ahead and compile this video. So as you can see, it is telling you that function base. This means this is a default constructor. It's missing because if you want to create this b1, this is a default call to the default constructor, whereas the default constructor is missing. Okay, but if just I will remove this copy constructor from here and we'll recompile this code is going to compile, and if you will run this, it will run. So it means there is no error in this code now. So why removing one constructor worked fine? I mean, what was the requirement here? So the only requirement is if you are giving constructor from your end, like any constructor, like parameterized constructor or copy constructor or whatever the constructor, in that situation you have to give default constructor. Okay, so that's the only rule. If you are giving any constructor, like this was a copy constructor here, okay, so let's suppose you can just give simply a parameterized constructor like this one. Okay, so in that case also you need to have default constructor. Okay, let's suppose this is provided, and we'll just go ahead and compile this. This is not going to compile now. See, again the same kind of error. Oh, there is some another error here. This one, we'll clear this. See, it is telling this is missing. Okay, obviously because we know the rule, if you are giving any constructor like parameterized constructor or copy constructor, in that situation you have to give default constructor if you are going to create a default object. There is no need of default constructor if you are not using that. Okay, so in that scenario I can just simply compile this. This is going to compile. Okay, there is no problem in this. See, this is compiling. So we are not using default now, so we don't need that. But if you are using that like this one, so this is the call to a default constructor, so in this situation it is error. Okay, so I think I'm done here. Let's look at the next video now. Hello guys, welcome to next video. Try to understand this. I'll count till 5, pause the video. 1 2 3 4 5. I think you would have come up with the answers by now, so let's go ahead and compile this. This is 43. 43. This code is compiling, so at least compile time error is not there. Now run this code. So the answer is base my function, base my function. So the answer is D here. Okay, why the answer is D? You are calling this my function with this new derived, and that pointer whatever you created is getting into this B. B is calling my function. So first time you are having derived pointer here, and derived also having this my function, but you are not calling this derived my function because we are not having any polymorphic behavior here. Okay, so in first case also you are calling this my function, and in second case also you are calling this my function, but in all the cases you are calling this my base function only. Why? Because your pointer is of base type here. Okay, so that's the reason behind you are calling this my function in both the cases. Okay, so I think we are done here. Let's look at the next video, and you will get the answer for this question in the next video. Okay, why it was working like this and what could be done to achieve different calls. Okay, so here is the runtime polymorphism. So we'll see that in the next video. So let's look at the next video now. So this is your next video, and this is a follow-up video. If you have not watched previous video, please go ahead and watch the previous video of this video, then you come to this video. You will be enjoying a little more. Okay, so the only difference is I have written this virtual keyword here. Okay, so try to understand what is happening. I'll just count till 5, pause the video. 1 2 3 4 5. I think you would have come up with the answers by now, so let's go ahead and compile this program now. This is 44, so 44, compile. I know compilation error is not there. Yeah, damn. Now this time we are getting this C as the answer, what we expected in the previous video. Okay, but that time it was not coming. This time it is coming just because this virtual keyword is there. So what is happening here? My function is this function. Okay, this function you are calling, and you are passing this dynamically created object. One time it is derived, another time it is base. Okay, and you are getting into the base as pointer, and you are calling my function on the object. So this time, first time it is getting a derived object, that's why you are calling this derived my function. Second time it is calling base, so it is calling the base my function. Okay, so how this dynamic thing is achieved? It's just because of this virtual keyword here. Okay, there is something called virtual table and virtual pointer are being created here. Okay, so I know I have not explained virtual keyword much in my previous videos, and I am planning to create a series of videos which will explain this, how this whole virtual thing work. Okay, so for now you just keep in your mind that just because of this virtual keyword we are able to achieve this dynamic behavior. Okay, and to give you a slight idea how this virtual work, let's understand it this way. In previous video, this is the previous question here, virtual was not there, so just see this, only virtual is the new thing here. Okay, so virtual was not there in previous video, so in that situation it was calling, see I have the output of previous video, base my function and base my function. Why? Because the pointer type b is base type, so it will resolve at compile time. Okay, so the address of this my function will be return always this function. We all know all the functions are having their respective addresses. Okay, so this my function is having its own address in the memory, this my function is having its own address in the memory. Okay, so when this whole compiler is this program is getting compiled, compiler will check, okay, this is a base pointer, so let's copy this base my function here. Okay, so whenever you will call this b my function which is of base type, it will always end up calling this function only. Okay, it will never call this function because there is no dynamic behavior involved in this. You have not written the virtual keyword there, and in this video what I am currently explaining, virtual is there. In that situation it is not going to copy this my function address here. Okay, because now it knows that okay, this base is having polymorphic behavior, so in that situation it is going to resolve the address of my function, whether it is going to be this my function or this my function, at runtime, not at compile time. Okay, before it was working here at compile time, it was copying this my function's address and placing it here, and that was happening at compile time. That's why you end up calling my base function all the time. Okay, but here it is not happening at compile time, it is working as at runtime. Okay, and whenever you will call this, it will resolve, okay, what kind of object I am holding. Okay, this base pointer can hold base address as well as derived address, so that time it will check, okay, I'm holding the derived address, then I should call derived my function. Okay, and if I am holding the base address, the base type object, then I should call base my function. Okay, so this is the only thing you should be knowing, okay, for this video. Okay, so I think I made my point. Let's move to the next video. And yeah, please, if you have any doubt or you want to discuss something, please comment out. Hello friends, welcome to another video. I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. So I think you have done your homework. Let's compile this. So this is 45. So 45. At least there is no compile time error. So answer. So the answer is 1020 1020. So let's look at this, why it is 1020 and 1020. And if you already got the answer, please move to the next video. So we'll see this base is getting this parameterized call. So in that situation you are just calling this one, and you are locally creating a base object. Yes, it is allowed. Okay, you can create a base local object inside the base class, and you can do all this stuff whatever is happening here. And yes, this is nothing but your this b. Okay, b is your this pointer, and you are assigning this local b into this one, which is nothing but a copy. Okay, so your b is now pointing at 10 and 20. Before pointing that, you just printed that. That's because you got this 10 20 and 20 in first case, and after that you're printing it here, so it printed next time. Okay, so this whole thing is a valid code. There is no issue in this code. You might find issue in next video. Okay, so let's look at the next video now. Hello friends, welcome to next video. I know it is looking like the previous one, but there are some changes here. Okay, so just try to understand what is happening here. I'll count till 5, pause the video. 1 2 3 4 5. So let's go ahead and compile this. I think you would have got your answer, and I know lots of people will get shocked here. So, oh, what is this? Yeah, so at least compile time error is not there. Okay, now let's go ahead and run this code. Segmentation fault, code dump. Why? It's because this base bxy is creating problem for you guys. Okay, what is this? It's kind of recursion call, you know. You created this v1020, end up calling this base. Now again you are creating a base object which is calling the same function here again, and next time you will come here and again you will call here. Next time you will come, call. So like this, it is a recursive call. That's why it is showing you a segmentation fault. Okay, I can directly show you that it's just because of this base bxy. Stay with me, I'll show you that. And this is 46 followed by 45.c. We'll compile this. We are going to run this, and it is telling you the segmentation fault. I will check whether it is creating that core file or not. Maybe it didn't create it. It didn't create it. So maybe, okay, so this time it created. Actually, I paused the video and tried some options here. There is something called u limit minus c unlimited. You need to set this in order to get this core file. Okay, before, as you can see, there was no core file here. Okay, so now there is a core file. So now we can debug it. gdb e.out and our core file. See, it is telling you the problem is at 8th location. So the problem lies here. It means it is being called all the time. Okay, so the answer for this is runtime error. Okay, after a long time we are having this runtime error, right guys? So let's look at the next video now. Hello friends, this is another video. I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. Oh, it was little fast. So I think you have your answer. So let's go ahead and compile this code. This is G++, question number is 47, compile. At least compilation error is not there. Now run this. Copy constructor and assignment operator. I think lots of people would have got your answers correctly. So the answer is C here. Okay, why C? Because B1 is getting created, B2 is getting created. These two are getting created because of this default constructor. There is no printf here, so no problem at all. Now this base B3 is getting created and simultaneously it is being initialized also. Okay, so here comes the problem for lots of newcomers, so that whether in this situation this operator is going to get called or this base constructor, I mean the copy constructor, is getting called. So always remember guys, whenever you are assigning to some object and that object is being created at the same time, okay, so this, you can see this B3 is getting created at this particular line and you are assigning that, it means you are going to call the copy constructor here. Okay, and copy constructors can be called like this as well. Okay, so now this is pretty clean that this time it is going to call this base one. Okay, so the parameter itself shows that, okay, B3 is an object which is of base type and it is passing B1. So this base and passing as base. So this is going to get called. Okay, so I can just show you that compiled and the same answer. Okay, so that assignment and this kind of calling is same here. Okay, but whenever you assign one object with another object and that object was created before, like this B2 was created here and you are assigning it here, so in that situation you will always call this operator function. Okay, you are not going to call this base, I mean the copy constructor, because that B2 was created not here, here. Okay, so this time you are not creating B2, you are just assigning it. Okay, B2 already have the memory for whatever you want to assign it. Okay, so that's it. This is the only confusion lots of people have. Okay, so I think I made my point here. Let's move to the next video. Hello friends, this is another video and this is not a revisit video. So pause the video and try to understand what is happening here. 1 2 3 4 5. I think you would have come up with the answers, so let's go ahead and compile this program. This is 48. At least no compilation error. if you'll run copy constructor is the answer for this. So there is this another way of calling your copy constructor. I explained this way in my previous video also. So this video will become like the exercise video for you. Okay. So I know lots of people would have given the correct answer. So let's move to the next video now. And yes, if you have any doubt or something, please comment out. If you want me to include some videos on some topics or something, please tell me that. Okay. I'll be very happy to get feedback from you guys. Okay. Thanks for watching. Let's look at the next video now. Hello friends, this is your another video. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you have done your homework. So let's compile this. This is not just 19, it's 19.1. Oh my god. There is a compile error. Okay, so the answer is 1 here. Okay, both options are same, no problem. So why it is creating the problem? Because you have written this constant here. If you are writing constant, you have to initialize it. Okay, you might be getting some thing like that here. See, should be initialized. Okay, so this is not initialized, that's why you are getting error. Okay, so whenever you write constant member functions, constant member variables, you have to assign them. Okay, or I mean initialize them at the same time when you are constructing them. And there is another way of initializing these constant, and that is initializer list. Okay, so if you have watched my previous videos, you will get the idea what I'm talking about. So this is it. Let's move to the next video. So this is your another question. This is little bit similar, but see, there are two base. One is with value, one is without value, and they both are doing this initializing. Okay, so what do you think? What should be the output here? Again, I'm going to count till 5 and you pause the video and just think. 1, 2, 3, 4, 5. Oh, it was very fast. Okay, so I think you would have come up with the answers. So we'll just simply compile this and check the output. What is this program? 3. Yeah, see, the error is compile time error, so the answer is D. Again, we cannot overload base integer, which means you are overloading base. You cannot do constructor overload. Okay, actually you can do, but this is like you are giving two functions with the similar signatures. Okay, signature means integer A and integer A. So compiler won't be knowing that in which case I'm supposed to call this one and this one. Okay, because they both are similar. That's why it is telling you cannot overload. If this one is getting something like float, then there is no problem. Just simple warning which is saying that you are going to initialize. Yeah, that is okay, but the main point is you can overload like this, but you cannot overload the exact function. The way exactly it works in like function, if you will call this function integer and you are going to create another function with the same signature like integer, then this is not allowed. Okay, these two are not allowed. At least there has to be some difference so that compiler can decide at which situation I'm supposed to call this one over this one or this one over this one. So there has to be some way, and that way is always your parameters, not the return type. Okay, so I think I'm done here. Let's move to the next question. Hello friends, this is your new video. Okay, so this time I have changed a very small place. This is static. Okay, I have kept static here. So if you know what is the behavior of static, in this case you will get the answer correct. Okay, so I'm going to count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you would have got your answer. So let's go ahead and compile this one now. This is 14.9. What is this? 2 here, right? So at least compile. Oh my god, what is this? Undefined reference to base y and x. Oh my god, this is a compilation error. Why compilation error? Look, the error itself is telling you the correct thing. Undefined reference to y. It means you are just declaring it. There is no definition for this x and y. Okay, whenever you write static data member inside class, you have to explicitly define it. If you are writing static in this class, you have not given the definition for this by writing something like this. You need to explicitly write something like this: integer base and then your variable name. Y is equal to, let's suppose 10. Or if you don't want to initialize it here, no problem. You can just simply keep it as it is. Okay, and another is x. Now this time if we will compile it, it will successfully compile for you. See, I will clear this screen, enter. See, it got compiled. If you will run this, it will give you 0 and 0 because you didn't initialize it. If you would have initialized it with 10 and 20, it will give you 10 and 20 as output. I mean 20 and 10 because I'm just printing x and y. Yeah. So I think you got the idea here, right? You cannot just simply write static integer x and y, I mean the static data members, without giving the definition for them. And this is not the definition, this is just the declaration part of this x and y. Okay, that's why you got that error before. Undefined reference to y and undefined reference to x. Okay, so I think we're done here. Let's move to the next video. Hello friends, this is your new question. I'll count till 5, pause the video and try to understand what is happening. 1, 2, 3, 4, 5. So I think you got your answer. I know you got your answer. Maybe, yeah. Compilation error is not there now. Compile is what is this? 3, 2, 7, 5, 6. It means garbage. Okay. So the answer is C here. Oh my God! All the time answer is C. No, I should not keep it like this. Why it is like this? And yeah, it is a garbage value. Yes, it is not changing. I mean, I don't know. It's not changing. Yeah, you can see that it's not changing. But still, yeah, it is a garbage value. And why it's a garbage value? Because whenever you call a parameterized constructor and there is this initializer list kind of initialization here, then there is a pattern. First, this will get executed, then this will get executed. It is not like this one will get executed first and then it will execute. No, there is a order. Okay. So whenever you call some parameterized constructor or default constructor or any constructor which is using this initializer list, then the order is first come first, second comes second. Okay, so the first one is initializing with y plus 1. So initially y was nothing, so it was holding a garbage value. You incremented that garbage value by 1 and you just copied that into x. Okay, next time you are going and getting that value, whatever you passed, 5 plus 1, 6. 6 is getting into this y and this whole thing is done. After that you are just simply printing that. That's why y is getting 6 because 5 plus 1 is 6 and this x was some garbage value. Okay, that's why you got this garbage and 6 as the answer. I think we are done here. Let's move to the next video now. Hello friends, this is your another video. Try to understand this. I'll count till 5, pause the video. 1, 2, 3, 4, 5. I think you will come up with the answers, so let's go ahead and compile this one. Oh, at least compilation error is not there. So, oh my God, the answer is D. Garbage, garbage. Oh, garbage, garbage. Oh, garbage. Oh, garbage. So, why garbage? You are having this x initializing with 10, but it is taking this x and this y, not this x. Okay, so just don't get confused here. This whole variable access thing is depending on the scope it is used in. Okay, so this print is a function and it is going to use this underscore x and underscore y, so it will look into its own scope. So its own scope is this one, starting curly braces and curly braces. You have not given any declaration and definition for this one, so it will go up in the hierarchy. Okay, so it works like that. So up in the hierarchy means it will look into this class first. So this class is having x and y, so it will directly take from here. Okay, it will not take underscore x from here. Okay, let's suppose you was not having this one, you are just simply having this y. Then what should be the answer for this? So the answer should be 10 and garbage. We can compile this and run this. See, 10 and this is garbage value. Okay, so as I told you, if it is not getting in this local scope, it will go up in the hierarchy and up in the hierarchy and up in the hierarchy until unless it reaches to the global one. Okay, so this is the global one. You cannot run from here to somewhere else because this is the end of this file. Okay, this compilation unit. And yes, it will look for the different compilation units as well. Okay, because you might be writing it like this: x turn integer x, and you are not giving the definition for this one, control x, and after this main itself you are giving this integer underscore x is equal to 30 here. Okay, so in this case this x will become 30 now. let's go ahead and compile this. See, 30. Okay, if you are not writing this extern here, there is a problem. Compiling, see, it is telling redefinition of this x. Okay, so it means by writing this extern here, you just declared it, and here you defined it. Extern means you are telling that I will be getting this underscore x from somewhere else. Okay, and that somewhere else is this one or the different file, like this is 51.cpp. I could have included some another file while I'm compiling, and in that file this underscore x could be there in that file, and that has to be in global scope. It should not work in, I mean, it would not work in from some local scope. Got the answer now? Let's move to the next video. Hello guys, this is another video, and this is not exactly a follow-up video, but still there is some video like this before. If you are watching this whole video in the series, you will notice this. Okay, so let's try to understand what is happening here. I'll count till 5, pause the video. 1 2 3 4 5, and then yes, this is the option always. Okay, so I think you have come up with the answers by now. Let's check this out. Oh my god, segmentation fault. That means runtime error. Okay, second time we are getting the runtime error, and the same reason. Okay, before, if you remember, I was calling parameterized constructor. Inside that, again I was calling parameterized constructor. This time I am doing the same thing, but with the default constructor here. Okay, so this whole thing will work like this. You will come into the main, you will try to create this B. This B will end up calling this default constructor. This default constructor is telling, I want to create another B. Okay, you want to create, no problem. You just go ahead and create that. It will call itself again. Okay, it will come inside, and another time it will tell, I want to create another B. Okay, you create. It will go and come back. It will tell, I want to create another B. So like this keep on happening. Okay, that's why it is a segmentation fault. If you want to see, I can just compile this whole thing with, what is this, 52, with this -G option. 52, where is that 52? Yeah, compiling and then running. It would have created a core dump file, then gdb, your executable, and the core. Okay, enter, and the run. See, it is telling you the error is coming at this line because you are calling again and again and again. Okay, so there is no error in this line actually. Actually, there is no error at all. The error is lying in the logic here. You are calling yourself again and again. This GDB is still very smart. It is telling you where the error is coming. Okay, let's try to do something like create some variable, global variable, integer glb is equal to, let's suppose 10, and you will keep on checking glb is greater than 0, sorry, less than 0, and I will do this. If it is yes, we'll return this. I don't know, we can write this return in this constructor, but still we can give it a try. Oh my god, not GLD, GLP. Oh my god. Compiling, it is compiling and it is running. Oh wow. Enter. Run, it is giving you the output. Okay. Inferior, exit. I'll run this. Yeah. So the answer is, I mean, these many zeros. So now at least this time you didn't got this segmentation fault because you have the termination condition. So I proved my point that it was working recursive. Okay. So when this GLB reached to the 0 and it got -1, in that case it is false. Sorry, in that case it is true and getting return here. And as it is a head recursion and you call yourself 10 times, that's why you are calling yourself 10 times with the printf also. That's why you are having this 1 2 3 4 5 6 7 8 9 10 11 12. Oh my god, why 12? Oh yeah, we are calling it here also. Okay, so maybe it's 11 time here and 1 time here. Okay, so that's the reason. But yeah, I think I made my point here. Okay, no need to explain much. It is a recursion, guys. Okay, So let's move to the next video. I will just undo this whatever I did here. Hello guys, this is your another video. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you know the answer now. Let's look at so let's compile the code. This is nothing but G++ 53. Compile successful, enter, run 10 and this one. So the answer is 10 and garbage. Okay. Oh my god, this time I didn't copy it here and here equal. I forgot that. No problem. So why it is 10 and garbage? Just because of this scope resolution operator, guys. If you are writing scope resolution operator at front of variable, it will get the global scope. This one. Okay. That's why it is taking this X from here, not from here. Okay. In previous, I don't know which video, but yeah, in previous video, I showed that if you are not writing this here, it will give you double garbage. See, double garbage. But because of this scope thing, you can directly get this X from here. Okay. So this is the way of accessing the global one. Let's move to the next video now. So this is a new video. I know if you know what is the scoping thing, you will definitely get this video. Okay. So let's look at the problem here. I'll count till 5, pause the video. 1, 2, 3, 4, 5. And I think you got the answer here. We will just simply compile this. Let's go and compile 54. Oh my god, compilation error. Why compilation error? You are using this scope resolution operator, which is telling you that I will be taking this X from the global scope, which is this global scope. Okay, this one, okay. But there is no underscore X here. That's why this error is coming, like underscore X has no been declared. Okay. So this namespace thing comes into this picture. Like if you are creating a namespace, you are putting this underscore X into this namespace, then it is not the global number. It is a global, but it comes under my space namespace. Okay. It is not a naked global variable. Okay, before it was a naked, like if you will write it something like this, then it is a global variable. It doesn't come under any namespace. Okay, so in order to access this, you can just simply write it like this. So just to show you that now it is going to work, we can just simply compile this one now. It is compiling and giving you 10 and 15. So for that matter, D should be the answer, but no. Our answer is compilation error. So compilation error, this one. Okay. So there is another tricky question in next video. So let's move to the next video. Hey, look at this question. It is little bit different, I know. So I'll count till 5, pause the video and try to understand what is happening. 1, 2, 3, 4, 5. So I think you would have come up with the answers. So let's check out that. This is 55. Oh my god, compilation error. Why? Why? Because, okay, we'll see this. Definition is not allowed here. I mean, this namespace is not allowed here. What do you mean by this? It means you cannot have namespace in local scope. Okay, inside the functions like main and any other function. Okay, it should be in global scope. So we can just simply copy this and paste it here, and I think it will work now. I'm sure, I don't think I know what it is. Okay, so it is 15 and 10. In that case, this 15 and 10 is the answer, but no, our answer is compile time error. Okay, so I think you understood what I'm telling. So let's move to the next video now. Hello Bangaloos, this is a different question than all the previous questions. So I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you got your answers. So let's go ahead and compile this one. 56. And yeah, it compiled. So compilation error is not there now. The answer is 21212. So 21212. D is the answer here. Congratulations if you got it. If you didn't, let's understand what is happening here. So the number 1 and 1 is calling this one. So, and this is calling number with 2 parameters. So the 2 parameters constructor is this one. So this integer a and integer b is being called. You are assigning that x with 0, y with 0, and you're calling this c out with 2 here. That's why that 2 was there in the first time. Okay, Now this call is done. You are coming back, you are going inside your constructor and you are printing this 0 just because this 0 is there, that is the reason. Okay, second time you are calling this N2. For this you are calling this single parameterized constructor, and this single one is again calling this double one. So this double one is getting called first. You are assigning this a into x, the same thing, and you are printing this 2. That's the reason this 2 is there. After that you are going inside and you are printing 1. So what you conclude from this? The conclusion is, whenever you call your constructor and that constructor is calling some another constructor, whether it is a parent class constructor or it's your own constructor. So if it is your own constructor, it is called constructor delegation. Okay, or even if it is parent class, it is called constructor delegation. No, I don't know, I'm not sure. Okay, just leave it. So if you are calling some another constructor from your own constructor, whatever you call from the first place, in that case it will not go inside this constructor first. It will just call that constructor first, it will complete that constructor, it will come back, and then it will go inside this constructor. Okay, I mean the own constructor it was calling first. Okay, so I think you got the answer. Let's move to the next video. So this is another question. So I'm going to count till 5 and you pause the video. 1 2 3 4 5. I think you would have paused and you are getting the answer now. So just let's go and compile this. Yo man, it's compiling and now you can just simply run and the answer is 10-0. Lots of people would have got the answer, I know. So I'll just simply explain what is happening here. B is initialized with 10. So this constructor will be called because you are passing only one parameter. Okay, so in this case this constructor is being called, and from this constructor you are calling another constructor with the value what you are getting from here, and for B you are having 0 value. If B is not passed, that means B is supposed to get 0 value. So this base is nothing but this one. Okay, so this constructor will end up calling and you will initialize A with A and B with B. This is totally new thing, so it is nothing but this one. Okay, you are initializing A with A and B with B. This is a new way of doing the initialization in constructors only. If you will try to initialize any variable in printf or some another member variable, this is not gonna work. Okay, so this is especially for constructors. And what is this whole thing? Why I'm calling this base and again calling another base? It is just because I don't want to write this initialization again and again. Let's suppose I want to create a default constructor. Like if you have created base like this only, base b1. Okay, so you are going to create an object which is not initialized with any value. Then in that case this constructor will get called and A and B will be initialized with 0. So if I'm not using this one, let's suppose I'm not using this one, then what I'm supposed to do is A is equal to 0 and underscore B. I'm supposed to write this one. Okay, and in this case let's suppose I am creating with one parameter like this. So I'm calling this one, I'm passing only A, the first one, and I'm supposed to initialize second one with 0. So in that case again I'm supposed to write something like this, like underscore A is equal to A and B is equal to 0. Okay, and in this case also I'm supposed to initialize. Okay, so why we are supposed to write all this initialization again and again? Why don't you just simply write a constructor call, which is nothing but this one only? Okay, this one. You are delegating the constructors here. Okay, this is called constructor delegation. I will make another separate video for this. Okay, this is just because of the MCQ purpose. So I think I'm done here. Let's move to the next video. Hello friends, this is your new question and I just didn't copy this one here to here. Let me do that. Yeah, so try to understand. I'll count till 5, pause the video. 1 2 3 4 5. Oh, it was very fast. 1 2 3 4 5. Okay, so let's go and compile this one first. Dun, dun, this is 47, compiling. Oh my god, what is this? There is a compile time error here, dude. Why? Because the reason is X is private within this context. Yes, you cannot use X like this if it is declared private here. Okay, no man, it is not just because your underscore X is private here. The reason is you cannot have this X here because it is not declared or defined here. Okay, so if you want to see how to initialize this x which is coming from here to here from this base number, watch the next video. So let's look at the next video now. So this is your next video. Try to think what is happening here. Okay, I'll give you a hint. This base is private base. Parameterized constructor is a private constructor here. Okay, so is this program going to compile, or what is the problem here? So I'll give you your time. I'll count till 5. Pause the video. 1 2 3 4 5. I think you got your answers. So let's check this out. This is 59. Okay, at least compile time error is not there. We will run this one now. Answer, and the answer is 10. Yoo-hoo, 1 0. It is not 10 actually, it is 1 0. Okay, there is a difference in between 1 0 and 10, and that is the difference here. Okay, so what you concluded from this B is getting created. So this B will end up calling this base default constructor. This base default constructor is using the constructor delegation method and calling parameterized constructor with the default value which is 0. And yes, this base is private here. Still you can call from the public base. Yes, this is allowed. This is private to the base class. Okay, but you can always call private method from the public method. Okay, and this is one kind of method only. Okay, so if you want to see error, you can just simply do something like this, like b1, and try to initialize something which will end up calling your base here. So let's go ahead and compile. This time it will give you error. It is telling this is a private thing. Okay, you cannot call it from outside this class. So this is private to this class. You cannot call it from outside, as this one is from outside and it is working just because this is public. I mean, this base is public, so you are allowed to call this from public area. Okay, but this B1 is supposed to call this parameterized base which is private, so you cannot call that. Okay, so that's why you are getting this error. Okay, read this out, it will tell you why it is happening. So let's move to the next video now. Hello friends, welcome to another C++ MCQ question, and this question is not very hard. Okay, so I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. I think you would have come up with the answers by now, so let's check out the answer now. So this is saying that it is having error at this line, like this base. So the error is this one. You cannot have something like this and then scope resolution operator. If you want to access base function which is exactly similar with the current function, you have to do something else, not this. Okay, and what? Let's check out the next video for that. I'll see you in the next video for this question. Okay, and the answer for this is compile time error. Okay, so A is the answer now. Let's check out the next video. Hello friends, as I said, I'll be giving that answer in this video. So this is the way we do that. I'll count till 5, pause the video and try to understand whether it is going to compile perfectly or it is going to crash in runtime or something. Okay, so I'll count till 5, pause the video. 1 2 3 4 5. So I think you will have come up with the answers by now. So let's check out the answer for this. So this is G++ 62, and yeah, it compiled successfully. We'll run this and it is giving you the answer is private. So the answer is 1. I mean A here. Okay, so why this friend class derived is needed here? Why? Because you are keeping this as a private. So if I will comment out this one, then in that situation it won't compile. Let's go and check that. See, it is telling you that function is private within this context. So you cannot call this function which is of base function from your derived class because it is declared as private in that. If you will remove this private from here, if suppose you keep it public, then there is no problem. We'll check that. See, it compiled successfully, and if you will run this, the same answer. Okay, so here we learn two things. If it is private, you cannot access it from here. Okay, so in order to make that possible, you have to keep your class inside this class as friend. Okay, and we all know that the reason behind using friend keyword in classes, it tells that this derived is my friend and this derived is allowed to use my private member variables and private data members. Okay, so whatever private is there, I'm allowing to this friend. and this friend is derived. So that's why we are allowed to use this. Okay, so I'll make it in original form. So this was the original form, and yeah, it is compiling, it is running, and the answer is private. Yeah, so we're done here. I'll see you in the next video. Hello friends, this is another C++ MCQ question, and this MCQ question is going to clear your doubt. Actually, that is not a doubt. People doesn't ask those type of questions what I'm bringing here. Okay, people don't ask questions because they don't know what questions to ask. Okay, so see, as I'm keeping this friend class, my class here, and there is no my class available here, and this base is telling that I want this my class to be my friend. Okay, and there is no my class existing here. So is it a problem or it is not a problem? Or I mean, what should be the answer for this MCQ question? So we'll try to see this here. Okay, I'll count till 5, pause the video and try to understand what is happening in here. So I think you would have come up with the answers by now. Now I'm going to tell you what was the main thing in this video. The main thing is this friend class, my class here. I am telling that I am the base class. I want my class as a friend. Okay, and in my whole program there is no my class. Okay, there are 2 highlights only. This is one highlight and this is one highlight. Okay, so there is only one my class keyword written here. It means this my class definition is not there. So how this whole program is going to behave? There's a reason I included this video in this. Okay, so we'll go ahead and compile this. Code 3. Yeah. Oh my god, there is no error. And if you run this, it will print I love C++. Okay, so we can conclude that if you are writing one class and you're telling that I want this class as my friend, even if this class doesn't exist, there is no problem at all. Okay, I can write any damn thing here and it is going to work. Okay, see, control save, I'll compile this, I'll run this, still it is working. Okay, but you cannot do this with any other thing, right? If you are telling that I will be using something, then you must have the definition for that, at least a declaration for that. But here we don't need anything like that. So we're done here. I'll see you in the next video. Hello friends, welcome to another C++ MCQ question, and this question is, I don't know what to tell. I'm going to count till 5, pause the video and try to understand what is the problem in this. Okay, 1, 2, 3, 4, 5. I think you would have come up with the answers. So let's go ahead and compile this code. So this is 64, right? We'll compile this and hold your heart, baby. Oh my god, there is this semicolon missing in here. Okay, if you will be giving this semicolon correctly, it will compile and it will give you the expected output as I love C++. So lots of people might have got this output and they might have thought that what is this MCQ? This is very silly MCQ. Why did I include this in my video? But let me tell you one thing, guys. People just don't see the concept, like how good you are in the concept. And they might be looking for the people like they are looking at the code. They know what is right and what is wrong. Okay, I have seen people like they will just scan the code and they are not supposed to run the code. They will just simply scan the code by their eyes and they will tell that this is the problem. And no matter how tough that line look like, they can directly tell you that okay, there is a problem. What generally people do, they will compile it. The compiler will tell you where is the problem. You will go and look into that. But generally in companies, if you are working on some big projects, sometimes it happens like you don't know where is the problem, because it is not compile time problem, it is runtime problem. And if it is runtime problem, and if it is not deterministic problem, so you have whole bunch of software, or I should say whole bunch of programs, you need to find the problem in that. Okay, so that time your keen eyes or your experience, I should say, will work. Okay, so this is not best suited example, like I just hide this semicolon. Maybe lots of people would have found it. If you found it, please comment out. I'll be very happy to see that. And even if you missed, you can comment I missed that, no problem. But this was not the silly question. Don't comment. Okay, so I'll see you in the next video. Bye bye. Hello friends, welcome to another C++ MCQ question, and this question is on virtual destructor. Is it possible? I will count till 5, pause the video. 1, 2, 3, 4, 5. I think you would have come up with the answers. So, we'll compile this code. Don't look at what is up here. So, it is 65. Oh my god, there is no problem in this code actually. And the answer is constructor and the destructor. So, the answer is C, baby. Why? Why? Because virtual destructor is allowed. Okay. And if you don't know what is this virtual destructor, please go to my channel, find why we need virtual destructor in C++. I have explained there. You'll be able to understand it very well. Okay. So we're done here. There is no problem in this video. I just wanted to show you this virtual keyword is allowed at front of this destructor. That's it. Okay. Let's move to the next video now. Hello there. Before we saw that, I was keeping this destructor virtual, but now I'm keeping this constructor virtual. Okay, so do you know we can write virtual at front of constructor or not? If you know the answer. If you don't know, wait for the answer explanation. Okay, so I'm going to count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. Oh, it was too fast. 1, 2, 3, 4, 5. Okay, I think you will have come up with the answers till now. So I'm going to compile this. This is 66. Rock your body, rock your body. Okay, so this is problem actually. You cannot have virtual constructors. Actually, the creator of the C++ told that we cannot have constructor virtual because we need to know what we are constructing. Okay, so C++ is not that kind of language which will keep the information abstractly that what it is going to create. No, you need to be very specific what you are going to create because it deals with, I don't know, maybe it deals with the memory, layout and all those stuff. Maybe it's because of that it is not allowed. There are a few programming languages which allow virtual construction. Okay, but C++ doesn't allow virtual constructor. And why it allows virtual destructor? I have got a video named what is the use of virtual destructor in C++. Please go and check out my channel. You will get it. Okay. There is playlist called C++ interview questions. You will get that video in that. So for this answer is compile time error because we don't have any virtual constructors. You cannot write this virtual here. So if I'll just simply remove this, I'll go ahead and compile this again. It will go and compile. If I'll run, the answer is constructor and destructor. Basically, this will become the exact same question as the previous one. Okay, so the virtual was the only difference here. So I'll see you in the next video. Hello friends, this is little bit of tricky, or maybe if you don't know the answer, you might enjoy in the end. Okay, so I'll count till 5, pause the video, try to understand what is happening in here. 1, 2, 3, 4, 5. I think you'll have got your answers by now. So let's go ahead and compile this code. This one is 67. Oh my god, there is no problem in this code and the answer is C. Yes. The answer is C. So if you have not found any problem in here, I will tell you that you are calling this static function on this object. Okay, b.static function. And we don't need any object exactly to call this static function, but still this is allowed. Why? Why? Because it is not doing any harm. People think like you should not do it because it is static function. But actually there is a difference. See, this is also a static function call and this is also a static function call. So what is the difference between these two? The difference is this B is going to get evaluated at runtime. Okay, and what do I mean by that? We can have something like eval function here. That eval function is returning this base reference and that eval is just simply returning base, or this will become the local, which is the undefined behavior. So for that matter, I will simply do it like b1 and return this b1. Okay, so I'm just simply showing you the case that what is possible here. This eval will return the base and this base will end up calling this one. Okay, so if you want to call some function like eval, before calling this static function, then you can have this chain behavior, and this chain behavior is not possible in this calling mechanism. Okay, in both the cases you will end up calling static function only, but here you are calling this function before, and after that it is returning this base and you are calling this function. Okay, and I'm not sure it is runtime behavior or it is compile time. Actually it is a compile time behavior, because it does know that, wait a minute, what it should be compile time, right? This function is getting called, yeah, actually it depends on runtime. Okay, this eval function will get called, this eval function will return this reference, on that reference you are calling this static function. Okay, so this is runtime, so we can just simply compile this code and check the correctness. Yeah, it is compiled successfully and it is giving you the same output. Okay, I can just simply print something here which will give you some idea. Okay, so let's compile this code again and see. Simple function is called here, simple function was called here. After that you call this evaluate, which is printing this eval function, eval statement here. After that you are calling this static function, which is printing this basic static, and at last we are calling this traditional way of static function call. Okay, so that's why this is the output here. I think you enjoyed the video and I'm done here. I will see you in the next video. Welcome to the next video, and this is your program. I'm going to count till 5, pause the video, trying to understand the program. 1 2 3 4 5, and I think you would have got your answer by now, so I will just go ahead and compile this one, and this MCQ number is 6. This is compiling successfully, so the compile time error is not there. Now I will run this program and the answer is 20 and 19. Okay, 20 and 19. The answer is A. Why it is like this? If you already know the answer, you move to the next video, and those guys who don't understand, stay here and I will explain that. So first of all, you have one variable initialized with 20. You're passing that variable x to the add function, which is nothing but this one, and you have created a copy of that. This 20 is not this 20 here. In that case, you are doing x plus is equal to 1. After that you are printing this, so you didn't change this x, so that's why you end up printing 20 here. And now you are calling this sub with x, but here you are getting with reference. So in that case, this originally created x is reaching here, and if you are decrementing this x, in that case you are decrementing this x, because you have get this x by reference here. Okay, so this is not the copy of your original one, this is original one itself. Okay, so you decremented it, that's why it is printing 19. I know it was very silly, but I just wanted to point that sometime you will really come across this kind of questions and you will really get confused that whether it is really that simple. So it was showing you the use of reference. So let's move to the next video. Hello friends, welcome to another C++ MCQ question. I'll pause the video, try to understand what is happening here. 1 2 3 4 5. I think you would have paused your video and come up with the answers. So let's check out the answer for this. So this is 68, and yeah, it is telling you that you cannot call this function without any object. Okay, so this function is not static function. This is a non-static function. You cannot call non-static function from static function. If you want to call, you must have some object existing here. So with the help of that object like obj dot simple function, and that obj is of type base, so we can just simply have it like here, base obj. Now it is possible. Now if you will call this, there is no problem and it will run, and base is static and simple function. This is the answer, but for our question the answer is compile time error. Okay, so let's check out the next video now. Hello friends, this is another C++ MCQ question, and if you found the answer by just looking at this question, don't blame me for putting it in this video series by saying that it was very stupid question. No, it is not a stupid question because I'm putting it here. Okay, so I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5, and yeah, don't forget that I'm keeping this easy question tag here. I have seen questions like this in MCQ questions. Okay, so I think you have got your answers. Oh, did I count till 5? I don't know. I'll count 5. 1 2 3 4 5. So I think you have come up with the answers. So let's go ahead and compile this. This is 69, right? Compiling. Oh, there is an error. What is this error? Cannot be overloaded. So the answer is you cannot overload function with the help of return type. Okay? You need to have different parameters. Like if it is function with no parameter, this should be with some parameter like integer x or something. Okay? So then there is no problem. See, we'll compile it. We'll get the answer. Okay? Let's look at the next question now. Hello guys, this is looking little bit clumsy here, right? So I will just do something like this. I will place this option here so that it won't look very bad. Okay, and no need to panic. Make it look little better. Okay, see. So this is your whole question, and this is the options you need to choose. Okay, so what is happening here? Try to understand. I'll count till 5. Pause the video. 1, 2, 3, 4, 5. So let's go and compile this code. This is 70 compiling. Yeah, there is no problem. We'll run, and the answer is base. So do we have any? Yeah, base and base. So the answer is D. So we'll try to understand what is happening in this whole code. There is this base class. I'm deriving this base class into this D1 and D2. So these two are derived class of this base class. And there is this function called interface. So at some time I am passing this 1 to this one, and if this passed value is not 0, then we will return this D1, and if it is 0 value, we'll return this D2. Okay, so D1 and D2. So at some point here you will get D1, and here you will get D2. Okay, and on D1 you will call my function. So D1's my function should be called, and here you will have D2. So in that case D2's my function should be called, but it is not calling that. It is calling base and base. Okay, and why? You will get the answer in the next video. So let's check out the next video. Hello friends, welcome to another C++ MCQ question, and this question is a follow-up question. So if you have not watched 70 MCQ question, please go watch that, and after that come and watch this one. Okay, so the only difference is this virtual keyword in here. Okay, and it is looking a little clumsy, so I'll just clean this out. And yeah, and this option has gone below, so I'll just keep it here. Control C. So options are here, and this is your question. So if you are new to this question, I will explain what is happening here. So this is one interface, and yes, I wanted to explain this also, that returning this reference is very important in order to make this whole thing work as you want it. Okay, and there is this virtual keyword. So first try to understand what is happening here. I'll count till 5. Pause the video, then only I will explain what is happening here. 1, 2, 3, 4, 5. I think you will come with the answers. So let's go ahead and compile this code. And this is 71, right? So this is 71. Yeah, it is compiling successfully, and if we are running D1 and D1 as expected. Okay, so if you have watched previous video, there this virtual keyword was not there. So if we will delete this virtual keyword and will compile this, it will compile, and the answer will be base and base. So what this virtual keyword is doing here, this virtual is telling, don't decide on the basis of what is the type of the object. Okay, in both the cases base will be the type of this one, and if you are calling this my function is of virtual here. Okay, so now in this situation you will have different my functions. So let's go and compile it line by line. So this interface 1 will be called here. So 1 will come here. If x is non-zero, then D1 will come here. So in that case you are just simply writing this D1 here. Okay, assume like that. And in second case you are passing 0, and D2 is coming because this is 0, so this won't get executed. So D2 will come here. So instead of this one, you are just simply writing this D2. Okay, assume like that. And this D1 is a different class and D2 is different class. And yes, this D1 and D2 are the global variables. If you don't know, I should tell that also. And this D1 is of type this D1 class. Okay, and each class has its own my function definition. Okay, and as the logic says that if it is D1, my function should be called from D1. Okay, so this D1 should be called here as it is calling this time. Okay, but this behavior we are achieving just because of this virtual keyword. If this virtual is not there, you will always end up calling base function only, okay, because it won't be decided at runtime. And if you are writing it virtual here, it will be decided at runtime. Okay, what is this D1 and D2, or what is the object? It will be decided at runtime. So I think you got the answers. Let's check out the next video now. Hello friends, this is another MCQ question, and this is very small, tiny, little question. The question is, what should be here to achieve object slicing? If you don't know what is object slicing, please go to my channel and check out my videos. There you will get what is object slicing in C++. Okay, so if you know, please choose the correct answer. I'll count till 5. 1, 2, 3, 4, 5. I think you would have got your answers. So the answer is this B. Okay, we can just simply compile this in here, put it here, we'll remove this. Okay, B is the answer here. If you have any doubt in this video, please ask, because it is very simple if you know what is object slicing. And okay, I'll explain what is object slicing. See, this B is having this B part as well as A part. Okay, but when you assign B object into A object, just simple assignment, one object variable to another object variable, not pointer or anything like that, simple object to object. Okay, in that case, if you are copying from derived to base, in that situation, base doesn't have any idea about your derived member variables and all that. Okay, so in that situation, the only material which is being copied here, I mean here from this B, is what is this B is holding as A's part, because this B is of derived type. Okay, and this B is having its base, its own type, and A type also, whatever the content is coming from A. So in order to explain that little more, I will just keep it like this. So if now you are assigning this B into A, then only X is going into A, because there is no Y in A. So from this B, you are going to copy only A part of B, okay, not the whole part. So that you sliced off the B part and you copied only A part into the A, that is called object slicing. I think you are clear. If you are still not clear, please watch my video. There I have given a good example. Okay, so let's check out the next video now. Hello friends, welcome to another C++ MCQ question, and this question is little bit different than all the questions you might have seen so far. Okay, and this is using some file operations here, and I just wanted to clear this EOF function here. Okay, whether this is possible or not. Okay, and this looks very easy. That what is happening here, it is just simply, I will not explain now. I'll count till 5, pause the video and try to understand what is happening here. Everything is written at front of you, and I can just simply show you the sample.txt file, what it contains. So it contains only hi there, I love C++, only this much. So go ahead, try to understand what is happening here. Okay, I think you would have got your answers. So I'm going to compile this code and try to see what is happening here. So this is 73.cpp. There is no problem in this code. Enter. Hi there, I love C++. That's it. So whole content was printed line by line. Okay, so what is the answer here? I also forget. Compilation error, no, while it is not end of the file, output file line by line. So maybe this is the answer, and we'll search for the end of line while it is not end file, print last line. No, so the answer is this one, B. It is checking one line and it is printing that. I mean, it is first pushing that into this buffer. Okay, I mean, it will get this 50 characters from my file, it will push that into buffer, and I am just simply printing that buffer. That's it. Okay, so let's check out the next video now. And yeah, please, if you have any concern, please comment. I'll be very happy to explain that. Hello friends, welcome to another MCQ question, and this MCQ question is about, no, I'm not going to tell that. I'll count till 5, pause the video and try to understand whether is there any problem in this or not. If you have followed my all previous C++ interview question series, you might get the answer for this one. So 1, 2, 3, 4, 5. So I think you would have come up with the answers by now. So let's go ahead and compile this. We'll compile this, and yeah, there is an error. It is telling that jump to a case label. And why it is like that? It is telling you are crossing initialization of integer x here. Okay, so the problem is here. You cannot skip integer initialization when you are creating it. Okay, so I'll explain you from the beginning here. Let's suppose you came into this switch. Now there is a possibility that you might come inside this one, or you will directly go to this one. Okay, so it is telling that this whole switch is one scope, and in that scope we have a mechanism to skip few instructions. Okay, and that skipping mechanism is this case. So if it is matching this one, it will skip all other cases you might have defined. So it will just go inside that and it will skip other. And let's suppose you have other cases like case 2 and case 3. So it might go into case 3. In that case, case 1 will be totally skipped. So don't assume that x is always initialized with 10 here. Okay, so if you are not initializing it like this one and we are compiling it, it will compile. See, it has compiled, and if we will run this, it will give some value because we have not initialized it. Okay, so the problem is you are creating it and at the same time you are initializing it. That is the problem, because generally people think if I have given integer x and if I will initialize it with this, so initially this x will hold 10, but it is not true until unless your program counter hit this particular instruction. This 10 is not going to get assigned into this x. Okay, and just assume this is whole one scope, because this curly bracket start here and end here. In this full scope you have the mechanism to skip some of the instructions, and you might skip this one and you may think that okay, I will use that x here like this. Okay, but this is not allowed. Don't think that even if you didn't came into this but x was created and it was initialized. No, that is not going to happen. Okay, so that's why this cross initialization of integer x, this error has come. Okay, so in order to achieve this, you just have to do this one. You have to enclose your case in scope. Once it will come into scope, then there is no problem. And yeah, if it is in this scope, obviously you cannot use outside of that scope. That's why that problem is solved if you are putting that inside the scope. So now if I'll compile this whole code will compile. So let's go and compile. See, it compiled, and we will see 10 is answer. Okay, so if somewhere you see something like in cases, if some variable is being initialized, you can straight away tell that okay, there is an issue in this. Okay, and you know the answer for that. It is not scoped. That's why it is coming as a compilation error, because you might miss that instruction getting executed and still you will expect some output. Okay, that is the problem with that. So I'm done here. Let's look at the next question now. And if you like the question, please hit the like button, or you have any comment, please comment below. I'll see you in the next video now. Hello friends, welcome to another MCQ question, and this is not typically a C++ question. You can consider this as C question also. So I'll count till 5, pause the video and tell me the answer. 1, 2, 3, 4, 5. I think you would have come up with the answers. So let's go ahead and compile this code. This is 75. We'll compile this. There is no compilation error at least. Now run this code. So the answer is 1 and 4. A is the answer here. If you are surprised, I'll explain that what is this. If you are not surprised, you know that, you can watch another video. Why v1 is initialized with 1 and why v2 is initialized with 4 here? It's just because when it comes to comma separation, every individual instruction, whatever is separated with comma, is a single statement. Okay, so this is one single statement. Don't think like after this equal sign you are having 1, 2, 3, 4. No, after this equal sign there is only one thing, which is this 1 here. After that another instruction is getting created. Okay, and after that another instruction, after that another instruction. These things are like 2, 3, 4 are not supposed to do with anything with this initialization. Okay, that's why this v1 was initialized with 1 only. After that this 2, 3, 4 came. And don't think that you cannot keep like this one. You can always keep these things, like if you'll keep like 4 here, 49 here, 20 here, then also this code will compile. Let's check that. See, it compiled and there is no problem in this code. Okay, so you can keep this. That's why there is no error keeping it here. Okay, and as you can guess why 4 was assigned into this. So we all know that once it comes to this round bracket, this whole thing will become one instruction. Then whatever the result of this instruction would be will go to v2. Okay, so after this equal sign, only one instruction is available. Inside that there are lots of instruction. Okay, but for v2, whatever the result of this single instruction will come is gonna go into this v2. Okay, so the rule of comma is it will execute from left to right and the rightmost result will be considered. So that's why this 4 is being considered here. Okay, in case of single instruction option. So if you are not getting what is this single instruction thing, I'll give you another example. Let's suppose there is another function called function, and that function is just simply returning 1, 2, 3, 4 here. Okay, and we all know that return returns only single value. Okay, so this whole thing is considered as single entity. Inside that there are lots of statements separated by comma. Okay, so 1, 2, 3, 4. Okay, or so whatever the result would be, that single result is going to get returned. Okay, so we can just comment out this and we'll see that. And fun and good to go. So I'll compile this code, and if we will run this, 4 will be the output. See, why 4? Because this whole thing was considered as single entity, and I told you that comma separation rule is it will execute line by line and the final result would be considered is the last one. Okay, that's why this 4 is getting returned here. Okay, so I think we are done here. If you like the video, don't forget to hit the like button. I'll see you in the next video.
Hello friends, welcome to another C++ interview question, and this question is about what would be the size of your base class here. Okay, so I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you have got your answers. So let's check out this. And question number is 76. It's compiled successfully, so at least compilation error is not there. So the answer is 4. So what do we understand by this? This static variable doesn't contribute in the class size. Okay, I mean the object size here. But it doesn't mean that it is kind of a global or something. No, it belongs to this class. But the size of the class would be 4 byte only, just because we are having this integer x here. Okay, this one. But you cannot access this static variable without this base scope resolution operator. Okay, so we will see that if you will give this print, like if you want to print it, then you have to use this. Now we'll compile this again. It is telling you something. Oh my god, what is this? Oh, sorry, it is obvious that it is private, so you won't be able to access it. Now we can access it like this. We'll run this 0 and 4. So the value in this is 4. You cannot access this STK without this base. Okay, check that. See, STK was not declared in this scope. That means this static variable is inside this base but doesn't include its size in that. Okay, so we are done here. Let's move to the next question now.
Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++ MCQ questions, and this video is about returning array from some function to another function and using that. Okay, so as you can see, we have this main function calling this fun here. We're coming here, created this array of 3 size 1 to 3 initialized, returning array, coming back because this array is integer pointer, so returning integer pointer, getting it into integer pointer and just printing all these three values. So everything is looking pretty clean, right? So tell me if there is a problem in this code, and I'm telling you, definitely the problem is there. Try to find out. I'll count till 5, pause the video. 1, 2, 3, 4, 5. And I think you have come up with the answers. So let's check this out. Let me just run this. Okay, it is running. And boom, it is failed. So it is a runtime error, this one. Okay, but why it failed at runtime? And see, this is one pretty clean warning. The address of local variable ARR is returned, and our runtime fail was just because of that, because this is local to this function. I mean, this array is local to this particular function, and we are returning the address of that. This ARR will hold the address, okay, and we are returning that, coming here and trying to print those values. But wait a minute, when there is something local to this function or any other function and you are returning that as an address, then there is a problem, because if that thing is local to some function, as soon as that function is completed, that thing will get destroyed, and that's what happening here. You return this address of this ARR, assigned it here, but as soon as you come out from this function, this ARR is destroyed. That's why you're trying to get this here and you're failing at runtime. That is the only reason for this failing. If you want to check that, let's make this static, and we'll compile this. You will get the desired output. See, 1, 2, 3. And we all know the behavior is static. The behavior of the static is wherever it is used, it won't get destroyed until unless you are returning from the function. I mean, this main function. Or to say, you're terminating your whole program, then only this static variable will get destroyed. Until unless this won't get destroyed. Okay? It gets created only one time and remains till you hit this return 0 and come out of your main. Okay? So in static case, I'll tell you what happened. You call this function, you came inside this, you created this one, you're returning this array address, coming back here, but as it is static, it won't get destroyed and you will be able to print the values. Okay? So that's why you are successfully printing that. See, 1, 2, 3. Okay? That's it. I hope you liked the video. Don't forget to hit the like button if you did. And make sure you subscribe to my channel if you haven't already, because I'll be publishing videos like this very often. Thanks for watching. I'll see you in the next video. Bye-bye.
Hello friends, welcome to another C++ interview question. This question is about how the constructors are being called in the case of this inheritance and all that. Okay, so you might be knowing this and it might be a silly question for you, but still as I'm going to cover everything, we should cover this also. Okay, so I think you would have got your answers. So let's go ahead and compile this one. This one is 78, so there is no compile error, and the answer is this one. And yeah, there is no option here just because sometimes it becomes really very big like this one. Now I will be keeping something like this so that whatever the answer you are thinking, just keep in your mind and at last we will see that. Okay, so for now, as you can see, this base 1, base 2 and derived is called. So you are creating this derived object here, which is D, but in order to construct this D, first base is being called here. Why? Because it will check the hierarchy, like it will go to the derived class. Now it is checking that, okay, it is inheriting base 1 and base 2. So now there is a question like, which one will get executed first? So the rule is, whoever is written, I mean, whatever the class name is written here, first will be executed first here. Okay, because for this one, these two parents are just immediate parents. So how to call the constructor? Okay, so base 1 is being called just because base 1 is written here. So if I will change this, like if I will make this B2 and if we will make it B1, so now the order will change. So let's check that also. See, first B2 is being called, then B1 will be called, then derived will call. Okay, so this is what the motive was, to show you that how this thing works. I mean, this derived will call this place constructor first, then it will go for this place. and then this place and all consecutive places. Okay, so it's like first come first serve. So we're done here. Let's move to the next question now. Hello friends, welcome to another C interview question, and this question is going to be a little bit more interesting than the previous one. And why? You will see that. I think you would have got your answers by now. So let's check out the answer for this. So I'm going to compile this. This is 79. Enter. There is no compilation error. And the answer is 10 and 20. So if you are not surprised, be with me. I'll solve your doubt. Okay. So this thing, whatever you're seeing here, is called conversion operator, and this is called conversion constructor here. Okay. So if you have followed my all the videos, you might get this conversion constructor here. And something is called conversion constructor when it gets only single argument. Okay, so this is a single argument constructor. That's why it is a conversion constructor. We'll see that in a moment. What is this conversion constructor? And please notice this: you are not giving any return type here. Okay, so conversion operator doesn't give any return type because the return type is always fixed. So what do I mean by fixed here? So we'll try to understand this whole code, then we'll understand it better. So let's suppose you created a base B, which is this one object, and you pass this 10. So this 10 will get assigned to this X. Everything is okay till now. Now you're passing this B, which is of base B type, to this function. But here this function is taking base A type, okay, which is not inherited here. Notice that. Okay. So ultimately what you are doing, you are trying to do something like this. Base A is equal to base B. Okay. And this is the function which will help you to achieve this. You cannot initialize one object of one class to another object of some different class without writing the conversion operator here. Okay. So where the conversion operator will come? If you are assigning B to A, that means B should have a conversion operator which will tell you how to convert it. Okay. And this is the way to write it. Writing constant is must here. Don't forget to write the constant here. Okay. Because you are going to assign this object to this one, and you want to make sure that you are not accidentally changing this one. Okay. That's why this is a constant. So I think you got the syntax. We are assigning base A type. That's why we are returning base A type here. Okay. And it doesn't matter what you are doing. I mean, you are calling with some parameters or not. That is not the issue here. Okay. The main thing to remember is you are not writing any return type. So we were talking about this initialization. So this B is being assigned to this A with the help of this. Okay. So this one is being called, and you are returning base A with this X. And this is the interesting thing here. Another one, 20. This 20 is being assigned to this base A here. And how this is working? This one is directly talking to this class, and it is calling this constructor. Okay, this conversion constructor, just because it is having only one parameter here. If I'll remove this, we get error. See, it is telling there is no matching function. So this is the only reason we use that explicit keyword here. So if it is explicit, then also it is not allowed, and this explicit is used for that purpose only. We'll compile this again. It is telling you that you could not convert 20 from integer to base A because it is explicit here. You need to cast it explicitly. Before, what compiler was doing? Compiler was implicitly calling by watching this 20 is being assigned to base A, and we have one constructor which takes only one argument. Okay, so pass that argument to this constructor and construct it, and there is no issue. But if you don't want that facility, you can type this explicit keyword and compiler will not do that. Okay, so you already saw this one. Okay, as we are getting the error here. Okay, so I think we are done here. Let's look at the next question now.
Hello friends, this is looking a little bit similar to the previous one, but there is really a big problem in this code. So if you can spot the problem, you can comment out that really I spotted the problem. Okay, so I'm going to count till 5, pause the video. 1, 2, 3, 4, 5. And I think you would have got the answer by now. So let's go ahead and compile that. G++, what is this, 7, done. Yeah, so the problem is you cannot have function with reference and calling with the constant, and which is nothing but the R value. Okay, so this is R value, this is L value. So I don't know, maybe some of the people will not be knowing what is L value and R value. I'm going to create the video for that. If you are watching this video and you don't know what is R value and L value, you just Google it. If you don't understand, you come here, I'll explain you that. Okay, for now I will just tell you this is L value and this is R value. R value is mostly the constant, I mean all the time it is constant. Okay, and L value is variable, and variable means you can change it, that's why its name is variable. So you can get the reference of variable here, X. This is valid call. If you noticed here, it is giving you error at this line, which is nothing but this one. And the problem is you are going to pass some constant which is 10 and going to get the reference of that, which is not possible here. Okay, so that's why it is compile time error. I'm going to give you the answer for this in the next video, how to achieve this kind of calling. Okay, so let's look at the next video.
Hello friends, welcome to another MCQ question, and this question is about multiple inheritance. We are having this B and C into this D. So what is the consequences of multiple inheritance when we are having the similar base class like A here? So pause the video and think about it. So I think you have come up with the answers by now. Let's look at the answer for this. This is 80 and 80. Okay. Oh my god, this is a coincidence. Question number 80 is having answer as 80 here. So why it is 80? If you know the answer, I mean it is really very simple thing. If you don't know, you can stay into this video, I'll explain that. We'll try to understand with the help of this diagram here. We are having one A here, B, C and D here. B and C both are inheriting this A, and D is inheriting this B and C here. And this A is having this array of integer which is of total 40 bytes here, because integer is of 4 bytes, 4 into 10, 40 bytes. So this A is having 40 here. Okay, so if you are inheriting this 40 here inside this C, then 40 is coming here, and the same way 40 is coming here also. And now you are inheriting this B and C into this D. So in that situation, we are having this 40 here plus another 40 equal to 80 here. Okay, so that's why it is 80. Got it? Yes, it is 80. And we are having 2 time array into our D class. Okay, so if you want to simply access this array with the help of this D class, you will have to use scope resolution operator, and we will see in the coming videos that how we will access the array from D. Okay, there is a way of getting that array only single time into this D, and we will see that what is the way in coming videos. Okay, so for now the answer is 80. Okay, so we are done with this video. Let's look at the next question now. Hello friends, this is another MCQ question, and this is a follow-up question. If you have watched 80 question, then you will be able to understand a little bit better here. So in 80 I was not having this virtual keyword written here. That's the only difference I guess here. Okay, otherwise everything is same. So if you write virtual keyword here, then what would be the output? We'll see that. So let's go ahead and compile this. This one is 81. We compile, there is no problem. We'll run this. Now this is 48. So why 48? So answer is this E. But why not 40? Before it was 80. Like, okay, let's try to understand with this diagram only. And I'll be explaining about this virtual keyword here. Okay, so what is the significance of putting virtual here? Okay, so as we know, this array is of 40 size, so we will just simply write like 40 here, 40 will come here, and 40 will come here also. Okay, so this 40 is different than this 40. Okay, because this C will contain its own A part, and this B will contain its own A part. But when you inherit this B into this D and C into this D, then it becomes like 40, 4 and 4. So we'll understand what is this 2 times 4 here. So whenever you apply virtual inheritance like V here and V here, there is virtual table is getting created behind the scene here. And let's suppose there is virtual table here, and this VT1 is for this one. And let's suppose there is another virtual table, and this VT2 is for this one. These two tables are static table, and these two tables are created when your compiler is compiling your whole program, and it keeps this virtual table when the compilation is done, and it takes the initial pointer, this first address of this table and the first address of this table. Okay, so this initial pointer is copied into virtual pointer. So the memory layout of B would look like this. This will be having array here, this array which is coming from here, like this one, this array. Okay, so this array is of 40 size. Okay, we all know that. Now there is another 4 byte which is nothing but VPTR. Okay, and this VPTR is pointing to this virtual table here. Okay, and the same is for this C also. So this will also have this array here and VPTR. Okay, this is 4 size and this is 40 here. VPTR, this is 4 and this is 40. Okay, but when these two, this one and this one, get added and pushed into this D1, it becomes something like this. Okay, the order is almost like 4, 4 and then 40. Okay, so this is virtual pointer 1, this is virtual pointer 2, this 1 is nothing but your this one. Okay, and this 2 is nothing but your this one. Okay, and this 40 is either this 40 or this 40. Generally it is coming from left side, which is this B, and this B has become left because it is written first here. Okay, so whatever is written first here, generally base class variables come from that place. Okay, so this 40 is coming from this B, you can assume. In GCC at least you can assume that. Whereas there is no perfect description about that, but at least you can assume that much. Okay, so this is why this answer is 48 here. Okay, 4, 4 and then 40. So because of this virtual, 2 time virtual, we have created 2 virtual table. We included the virtual pointer of this table into this B memory layout, and virtual table of another is included into this C1. Okay, that's why if you will print the size of like B and C, it won't be like only 40, it will be 44. B will be 44 and C will be 44. We'll see that here. Let's suppose I have changed it, like B and C is there. Now if we will compile it, we'll see the difference. So let's compile this again. It will compile successfully, and check the answer here. So see, B and C both are 44, 44. Okay, so as I explained here, this is also 44 and this is also 44. But when 44 and 44 is getting added, only one time this 40 is coming, and that's what we wanted to achieve. That's why we use this virtual here. Okay, in the previous video you saw that if you are not using this virtual here and here, which is called virtual inheritance, if you are not using that, in that case this array which is having 40 byte is coming 2 times into this D. Okay, so we don't wanted that array to be coming here 2 times because there was no use of that, and there was ambiguity that what array we should initialize. Okay, so to remove that ambiguity, we are using this virtual keyword here. And there is a little bit of penalty which is called this virtual pointers and all is coming into the picture. Okay, and if you are not clear about what is virtual pointer and virtual table, you can go to the description field of this video and you will get that. Okay, there is video if I have created that so far, so you will get the video and you can understand what is this virtual table and virtual pointer meant for. So for now, the explanation for this video is this much only. Let's look at the next question now.
Hello friends, this is Rupesh. You're watching CP Minutes video series on C++ MCQs, and this MCQ I'm gonna write right now here. So this is base and this is gonna be a tricky one. So let's make this fun here, and no need to give the body part. That's it. And just define it as friend. That's it. And do nothing. Let's create this B here and we are done. So what will happen here? Is it gonna compile? Because the problem with this code is we have this friend declaration as friend, but we don't have any fun function here. So this fun function is declared friend, but it doesn't have any body. So is this gonna compile? I'm asking you. So this time I'm not giving any option like A, B and C, but still you got the point, right? You just have to say yes or no. Is it gonna compile or it's not gonna compile? So think about it. I'll count till 5 and you pause the video. 1, 2, 3, 4, 5. I think you might have come up with yes or no with your own logic, but I would say it is gonna compile. So let's check this. See, it has compiled in 0.05 seconds, so it's okay now. So if you are thinking why it is compiling, so let me give you the answer. This is a class and you created that class, okay? You are the owner and you are the developer of this class, and you are saying that some function named fun is my friend. It doesn't matter it exists right now or not. You are just saying that it may exist or may not exist. Some people might find this foolish because they might think that, okay, if this function doesn't exist, what is the meaning of saying that function as friend? But the point is, sometimes what happens, there are two teams in one development or one project. One team is in India or another team is USA, and maybe one team is developing one class and they want to keep some function as friend function, but they don't have the body. The body is developed in USA, not in India team. Okay, so in that case, you just got the declaration of the function, not the definition, correct? And when this full project will get merged into one project, there won't be any issue. And I think that could be the reason behind allowing this kind of things. Okay, so I will wrap up this video now. Thanks for watching. If you like the video, don't forget to hit the like button and make sure you subscribe so that you can get the notification for my upcoming videos like this. I'll see you in the next video. Bye-bye.
Hello friends, welcome to another C++ MCQ question. And this question is little bit similar to the previous one. Here I have removed the virtual keyword here. Before it was like virtual here. So I have removed this and we'll see what is the difference between this video and the previous one. So pause the video and try to understand what is happening here. I think you would have come up with the answers by now. So first of all, I'll go and compile this code. So this question is 82. So at least there is no compilation error. And if we'll run this, the answer is 84. So there are lots of people might have guessed correctly. So if you guess correctly, you can move forward and watch other videos. If you want explanation about this one, please stay here. I'll be explaining that. So as we know that in the previous video, I told that this is A here and B, C and D. The relation is this one. B is inheriting A and C is also inheriting this one. And D is inheriting this B and C both. But the only difference is we are having this virtual keyword here while we are inheriting this A into this B. So this virtualization is there in case of B, but it's not there in case of C. So as we saw the difference, and the answer for that was 84. Okay, so now we'll see why it was 84. If you remember the previous video, in that case we was having virtual here. Okay, and that was the key point. If you are having virtual inheritance in your parent class like B and C, and you are inheriting that B and C in some another child class which is like D, and both B and C or other classes also if you have, they all are inheriting the same parent class, in this case which is A here, with keyword virtual, then in that situation whatever the data members and everything will be there will be coming into this D uniquely. Okay, that is the use of this virtual keyword here. Okay, but what if we are giving only virtual keyword for one inheritance, not in another case like this one, what we are dealing with this now. Okay, so we'll see that what happens here now. So this A is containing this array, so the size is 40 here. This is having this virtual. So as we know, if you are having any virtual inheritance or virtual functions in your classes, you will be having virtual table and virtual pointer. So virtual pointer will be having this 4 size plus this 40. Okay, so this is for B. So here virtualization is not there, so in that case only 40 will be there. Now we'll talk about this D. D is inheriting B and C, but notice this, virtualization is not there in both the cases. That's why A will come from this place and this place also. So that's why you are having this 40 which is coming from here, this 40 which is this one, and this 4 also. So this total is becoming 84. That's why we are getting this 84. Okay. And now we will tell, if you will include virtual here, let's suppose here virtual, then here 4 will come, as we know that. But as in both the cases we have virtual here, the array what is coming from A to D will not be coming 2 times. Will be only coming as 1 time only. That's why the answer would be 48. Why? Because 40 will come as usual, but 4 will come from here and another 4 will come from here. So 40 plus 4 plus 4, 48 will come. So that's it. I think you got the answer here. If you have any doubt, please comment. Otherwise, let's check out the next video now. Hello friends, welcome to another C++ interview question. This question is about function call resolution. And what do I mean by that? So this is one function call, another function call. This is from A and you are inheriting that A into this B. It means you are overriding this call here. Okay. And again you are inheriting this B into this C, and there is no overriding or anything. And if you are creating this C, then which function would be calling here? Like if you are calling this call, this one will be called or this one will be called. So this is the question here. Okay. So think about it, pause the video. I think you would have got your answers by now. So let's go ahead and compile this one. No compilation error. It's B. Okay. So this is how it works. So let's try to understand with this diagram here. This is a diagram what we are having, this class relation here. So you are having this C and C is not having this call function. So B is inheriting this A is having call function, B is having call function. Now if you will create a call from C, so in that situation C is having both B and C, because B is inheriting A and C inheriting B. So C is inheriting B and A both. Okay, so in that situation you are having this call and this call both inside this C. So if you just simply write like this, like C.call, which one will be called? So in that situation this one will be called always, because it look in the hierarchy. Okay, so first it will always check into the immediate parent. If it is not found in that, then it will look into this A. Okay, so this is how it checks. So that's why B was called here. Okay, so always remember, whenever you have ambiguity in your mind, like which one will be called, like this one or this one, then just think which is the immediate parent. So C is having the immediate parent as B, so the B's function will be called. Okay, so I think you're clear. Let's look at the next question. Hello friends, welcome to another C++ MCQ question, and this question is about calling your constructors, and from that constructor calling a function which is virtual function. Okay, and it is overridden into your derived class also. So basically what is happening here, you are creating a derived class object which will result in calling this function. This is a constructor. This constructor will call its base constructor because we are inheriting it. Okay, after that it will call to this one, and this one will end up calling this function. Now we have this confusion whether it is going to call this function or this function, because we are having this virtual keyword here. Okay, so let's compile and check the answer for this. There is no compilation error, I know that, and the answer is base. So it is calling this function, not this one. Now listen very carefully. There is a rule says if you have function call from your constructor or the destructor, then even if that function is virtual, it won't be acting as virtual function. Okay, I mean it won't be called as the derived one, the object what you are creating, or simply we say the virtual keyword will not affect inside your constructor and destructor. Okay, and can you guess why it is not calling your derived, why it is calling your own class function? I'm going to explain you why it is not allowed. If it is allowed, then what you will do, you will call from here to here, and before constructing your derived, you will call some of your function where you can use some data member which is not constructed yet. Okay, so here let's suppose there is some variable x here. Okay, and you might change that x to something else if this function is being called, but this x is not created yet. because you have not completed your derived constructor. Before this, you have to call your base, and from base you are calling your function. In that situation, this is a very dangerous step. Why? Because you are changing something. I mean, you may change something which is not really constructed yet. So that is the danger part. That's why it is not allowed. Okay. So always remember, in constructor and destructor, this virtual keyword doesn't work. Even if you're calling some function which has virtual behavior, that virtual behavior is not going to work in that situation. Okay. Let's look at the next question now. Hello friends, this is another C++ MCQ question, and this is exactly not a C++ question, but you can expect this to come in your MCQ exams. Okay, so this is a little bit about type def, and there are some consequences of using this type def. So we'll see what is that. Okay, so pause the video and try to understand the output of this one. Okay, I think you would have come up with the answers by now. So let's go ahead and compile this one. There is no compilation error, and the answer is nothing. So answer is E, would not print anything. Okay, and why it is not printing anything? Because it is not creating the object. Type def means you are making this whole thing as one type. So this pointer is becoming a base pointer type. So ultimately you are not just replacing this with this one, like base and pointer here, because if you would have written it like this, then at least one time this constructor will call, because this t2 is going to get created here. T1 is a pointer type, but if you type def it, then this whole pointer itself is becoming base pointer. Okay, so whatever you write like t3, t4, t5, t6, all those objects will become base pointer type. Okay, this statement is not exactly the same as this statement. Okay, wait a minute. This one. Why it is not same? Because here in first statement you are telling that I have a base. I want to create the pointer of that, and which is t1. Okay, comma. I want to create object for that of base type, not this base pointer type, because this pointer is associated with this t1 here. But in this situation, you are telling that t1 and t2 both are of type base pointer, not only the simple base. Okay, that's why it is not creating any object here. Both are treated as pointers only. Okay, so I think we are clear here. Let's look at the next question now. Hello friends, welcome to another C++ MCQ question, and this question is a little bit tricky. If you don't know, something is there in this whole thing. I won't tell you now, so pause the video and try to find that. I think you would have come up with the answers by now, so let's go ahead and compile this. So there is no compile error, and the answer is 11 here. Okay, so if you got something else, let's understand why it is 11 here. Okay, so if you will notice here, first we are calling change x. So we are calling this function, and x++ is executed. We are returning this reference here. Okay, the reference means this a is changing itself with this function, and its x is changing. Initially it was 0, now it become 1. So for a, because we are printing a here, we are having x is 1. Okay, now as you see here, we are returning this pointer, and we are returning as reference here. So this whole thing from here to here will get replaced with a. So now again we are changing like a dot change y. This time we are calling this change y on a itself. Now change y is being called, y is also changed. So now y is 1, because initially it was 0, and that is returning not the reference, some, let's say, temporary, this t here. Okay, now you are calling that change x on this temporary variable, not on this a, and whatever is consecutively happening here is happening on this temporary or the temporary of this temporary, but not this a here. And we are ultimately printing a, like a get x and a get y. That's why we are getting this 1 and 1 only. Okay, so that's the reason here. So what you learned, this function chaining should be implemented on the basis of references. Okay, if you are not returning the reference type, it will become the temporary, and it might lead to the confusion. Okay, so don't miss out that reference. Sometimes you don't want that reference because actually it depends on what you are implementing, but people generally get confused with this. Okay, so this is a good question to ask in MCQs. So I think you got the point here. Let's look at the next question now.
So this is another video. This is a new function which I have added in the previous video. Okay, and rest of the things are same. So what do you think? What should be the answer now? And what is this double reference here? So just think or go and study what is this double reference. It is called R value reference. You can Google it and study and come back and see whether you are able to achieve the correct output or not. Okay, so for now I'm just going to count till 5. You pause the video. 1 2 3 4 5. So I think you would have come up with the answer now. You can just simply go ahead and compile this program. This is 8. No problem. So this time there is no compiled error. This is valid now because this is calling, this is calling this function and this one is calling this function. Okay, so you have overloaded add here. Okay, on the basis of L value reference and the R value reference. This is L value reference and this is R value reference. And in the previous video you didn't had this function. Okay, let's comment out this one if someone would have not seen my previous video, so they will try to get the glance here. If you are not having this function here, then there is the problem in this function call, because you are going to call with the R value and here you are receiving with the L value. So here comes the problem. Okay, so in that case I can just show you that it is not going to compile and it is going to tell you that non-constant reference of type integer reference. Okay, which is nothing but an R value. So you cannot get the reference of some constant. Okay, or in layman word you can say that you cannot have address of constant. Okay, this is purely a constant. Okay, you cannot have address of 10. There is nowhere it is stored in the memory. Okay, this is a variable and you can get the address of this. You can get only the addresses of variable, not the constant. You just try to understand that this is not the proper answer because this is R value and we do get where this 10 is stored by saying R value reference. So this is the way of telling that. Okay, so I think you have got your answer by now. Let's compile this and the answer is 21 and 21. So answer is B here. Let's move to the next video. If you have any doubt, you just please comment out. I'll be very happy to help you.
Hello friends, welcome to another C MCQ question, and this question is about this constant keyword here. So this function is a constant function. Okay, so if you know what is this, you can guess this correctly. So pause the video and try to understand this. I think you would have come up with the answers by now. So let's go ahead and compile this. So let's compile this. Oh my god, there is this compilation error. Actually, this constant variable is for making this function constant so that you won't be able to change the member variables inside this function. Okay, so we are going to change this x here. That's why it is telling you this error that base x is read only object. Okay, so this x is a read only stuff. You cannot change that inside this set x. Okay, so that's it. Let's look at the next question now. Hello friends, welcome to another C MCQ question, and this question is about this mutable keyword here. So if you know what is the use of mutable keyword, you go ahead and watch another video. Otherwise, stick to this video. I'll show you something new today. So as we saw in the previous video, if some function like this function is a constant function, this is the syntax of writing some constant function. If you don't want that function to change your data members, like this x is a data member, you don't want to change that, then you can write some function as constant. Okay, so this x cannot be changed, but this x is allowed to change because you are keeping this mutable keyword here. So you're telling that this x is a mutable variable, you can change it in constant functions. Okay, so let's compile this. This is 90, compile, run. It is running and the answer is 10 here. Okay, but let's suppose I am not keeping this and compile this. It will tell you the error, like this is a read only part in this set x. You cannot change this x because this function is a constant function. Got it? But if you are writing this mutable keyword here, which gives the power to this x to get changed even if the function is a constant function. Okay, not only this constant function, it can be changed in any constant function. This mutable keyword tells that only. Okay, let's suppose you are having some another variable here and you are going to change that variable here, then this is not going to work. Let's compile this. See, this time it is telling that error is here. See, it is in red sign and it is showing this, that this is the error. So when you are going to assign y, it is telling you the error. Okay, you cannot change the normal variables in constant function. If you will make this also mutable, it will work. Okay, so let's compile this. See, it compiled and run this, it is running. Got it? I think we're done here. Let's move to the next question now. Hello friends, welcome to another C++ MCQ question. So pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have got your answers by now. So let's go ahead and compile this. It is 91 and this is an error. And it is telling that your object is a constant object here and you're calling a non-constant function on that. So that is not allowed. That's it. Okay. So if you'll make this function constant here, it will start working. Let's check that. We'll compile it again. See, it compiled. And if you will run this, the answer is 0 in that case. Okay. So we're done here. Let's move to the next question now. Hello friends, welcome to another C++ MCQ question. And this question is about these conversion operators. So be careful with this question. Pause the video and try to understand what is happening here. I think you would have got your answers by now. So let's check this out. This is G++. This is 92. So there is a compilation error and it is telling that call of overloaded function my function is ambiguous. Okay, so this my function is a ambiguous function. Why? Because you are passing this b, which is of base type, and base type can be converted into a type and integer type. Okay, so if you are calling from here, compiler really don't know which function you are going to call, because you have conversion operator for both. Okay, you can convert base into a and into integer as well. Okay, so that's why it is confused whether I should call this one or this one. That's it. So this is a compile time error. Okay, if you have any doubt, comment in the below section. Otherwise, let's move to the next question now.
Hello friends, this is Rupesh and I'm watching CPP Nerd video series on C++ MCQ questions, and this question is based on yesterday's video about assignment operator overloading. And there we discussed how to assign a different data type to another type. So this is T1 of test type and this is B1 of base type. So we are initializing B1 into T1. So both are different data types. That's why we have to overload the operator here, and we have overloaded it. So this T1 will call this particular function and pass B1 as an argument. So T1 is initialized with 10 and B2 is initialized with 20. And this is the B2 code, and we have this constructor. So everything looks cool, right? We have this assignment operator overloaded. So this will be done. T1.print is there, so it will print that. So everything is looking pretty clear here. So can you find the problem? There is a problem. So can you find that? Answer is not 20. Answer is compile time error. This is first time I am telling you the answer in the advance, because it is little hard to find the error. So if you found it, please comment. It will be nice to see that comment. And I hope you would have found it. So let's compile this. So if we'll compile this, it will tell you the error, what the error is. Error is this integer x is private inside this base class, and you're trying to access that here. Okay, so as I said, this b1 will be passed as a parameter, so b1 has become RHS, and you're trying to access that x which is there inside this base class, but that is private, so you cannot access that. So you remember what I did? I made this full class as friend of mine, so friend class test. So if you will compile this now, it should work. See, now output is 20. And I hope you would have got it correct. So I think we're done now. Thanks for watching, and I'll see you in the next video. Bye-bye.
Hello friends, welcome to another C++ MCQ question. And this question is a little bit silly. If you know what is the size of virtual functions, then you skip this video. Okay, so pause the video and try to understand what is happening here. I think you would have got your answers by now, so let's go ahead and compile this. Answer is 48. So why 48? Here your A is of 4 byte because of this integer x here. Now your B is 4 from here and 4 just because of your this virtual keyword here, because whenever you have virtual functions in your class or you are inheriting through a virtual keyword, then in that situation your class will have a virtual pointer. So the memory layout of B would look like this. This VPTR is there and this X is there. Okay, so this VPTR is nothing but a virtual pointer. Okay, and this is virtual table which will hold this show function's address. Okay, so let's just simply write the show function here, and the initial address of this virtual table is this VPTR. Okay, so VPTR stored in this one. Okay, that's why the size of this has increased by 4, because this is a pointer. In my system it is 4 byte. And how this VPTR is getting into my object B, which is this one, the constructor does that. So I have not given any constructor. Even if I'll give any constructor, the compiler will include that code which will create VPTR and put that VPTR in all the objects. That VPTR will be similar in all the objects. Okay, that holds the address of your virtual table's first address. Got it? So this VPTR is coming through the constructor of B. Okay, that automatically includes this VPTR in your objects. And don't think that if you will include another virtual function that will include your object size by 4. No, it's just one time penalty. Okay, so if let's suppose if you are having this show function like suppose show2, in that situation your show2 will come here and nothing is going to change. This VPTR is again pointing to this one, and whenever you are using that show2, that offset will change. Like this is 1 offset and this is 0 offset, so it will check whether it is using show2 or show1. So if it is show2, it will give the offset of 1, so directly this function will call. So that is the mechanism how this virtual pointer and virtual table work. So I think we're done here. Let's move to the next question. Hello friends, welcome to another C++ MCQ question. Pause the video and try to understand what is happening here. I think you would have got your answers by now, so let's go ahead and compile this. Oh my god, there is an error. It is a compile time error actually, and the error is, actually there are two errors. One is your static member cannot be initialized using this initializer list. See, the error tells that integer x is a static data member. It can only be initialized at its definition. Okay, so this is static, you cannot initialize like this because this is not the part of your object, it is part of your class. And second error is this static function does not have this pointer. Okay, so if you will remove static from both ends, it will start working. Okay, so let's compile this again. So it is working and the answer is 3. So for that case answer is B, otherwise compilation error. Okay, so let's move to the next question now. Hello friends, welcome to another C++ interview question, and this question is about virtual keyword here. Okay, so pause the video and try to understand what is happening here. I think you got your answers, so let's check this. There is a compilation error, and that error tells you cannot have this B as object here because this B is of abstract type here, because you are not implementing this show function. This show function is not this show function because you are not having this integer here. Okay, so don't miss out that part. Equal to 0 is a pure virtual function. So if something is pure virtual function and you are inheriting that class in your class, and if you are not giving the definition of pure virtual function which is declared in your parent class, then your own class become abstract class and you cannot create the object out of it. You can create the pointer of that, okay, but not object. So if I will create this as integer here, then it will work. Let's compile this. Okay, see, it is working. So what you learned here, if you are having this show function as pure virtual function in your class and someone else is inheriting your class and not giving the definition of this pure virtual function, then that function is also, that class is also becoming an abstract class. And this class is also an abstract class because you don't have the definition of your function. So you don't know the actual work of this function in your class. That's why it becomes abstract. That's why you cannot construct this class because the full information is not available right now. Okay,
So I think we're done here. Let's move to the next question now. Hello friends, welcome to another C MCQ question, and this question is a little bit similar to the previous one. There are only these two lines which is the difference, okay? And I'm reading something new here. So pause the video and try to understand what is happening here. I think you would have got your answers by now, so let's go ahead and check this. There is no compilation error, and the answer is success. So this first is the answer here. You might have noticed here that this show is a different show than this one. As I explained you in the previous video, we have to give the definition of this show into this class, then only we can create the object of that. But notice here, we are not creating the object, we are creating a pointer. So if you will remove this pointer from this place and you try to compile this, it is going to give you error, okay? Saying that you cannot create the object of abstract class, because this has become abstract because you have not given the definition of this show here, okay? So if you'll write another show which is having this integer in that, so show, and we'll take integer here, then there is no issue. Let's compile this again. See, there is no issue and this will run. Got it? So you can have pointers of abstract class, okay? So we're done here, and let's look at the next question now. Hello friends, welcome to another C interview question, and this question is about this static variable and returning the reference of that. So is it possible? Pause the video and try to think. I think you have got your answers by now, so let's go ahead and check this. So there is no compilation error, and the answer is 110. So answer is D here, sorry, E here. So let's check out the working of this one. This is my function. So first of all, this will get called. It is calling this one, and we all know that this static variable is having scope of this function. So if it is created inside this function, it has function scope and it will stay alive throughout the program. So this stack is created, assign 100. You are returning this stack but with reference, so that this stack is also pointing to this stack only. Now you are changing this stack and adding this 10 to that. So this stack is now 110, and again you are calling that function which is returning that exact stack, and this is not going to execute again, because if it will execute again, this will not be available throughout the program. It will change, but no, it is the rule that static variables stay throughout the program after creating them first time, okay? So once it is created, so it won't get destroyed throughout the program, and that 110 is coming here and you're just simply printing that, okay? So that's it. Let's look at the next question now. Hello friends, welcome to another C interview question, and this question is about this inner class and outer class relationship. So check this out. This whole inner class is in public section of this outer class, and we are going to create the object, but inner class is having this constructor in private section. So whether it is allowed or not, you have to think about it, okay? And the same is applicable for this getX function also. This is also in private section, okay? So think about it. I think you would have got your answers by now, so let's go and compile this. So there is a compilation error which says that there is this object is non-constructible just because it is in private section, because this constructor is a private section. So it doesn't matter your inner class comes under public class of your outer class, the rules are same. If you want to construct some object, that constructor should be in public area, okay? So this is not in public area, so constructor is not being called. That's why the first error is this one, and second error is this one. This is also in private section, so you cannot call that. So if I'll put both of this in public section, it will work. See, and the answer would be 10, okay? But for this, the error was at compile time. So I think we're done here. Let's look at the next question now. Hello friends, welcome to another C interview question, and this question is about a reference data member variable. So whether it is allowed or not that you are giving this local scope reference to this base class variable, okay? Because you're passing this x here inside this b, it means you're passing a reference of this x, because you're getting it as reference here and assigning the reference to this x, okay, which is this underscore x. So pause the video and think about it. I think you would have got your answers. Let's go ahead and compile this. 99.cpp. There is no compilation error, and the answer is 10 and 20, which tells that
it is possible to have a variable here and pass its reference to this data member. And if you will change this variable, you will end up changing this data member indirectly, okay, because this is the original variable and this is the reference of that. So that is possible, okay. So let's look at the next question now.
Hello guys, this is Rupesh and you're watching CPP Nerds video series on C++ MCQ questions, and today we have this MCQ related to the size of the structures, so it will be a good fun. And yeah, I have uploaded the video for this just 2 days back, so if you have watched that video you'll be probably getting the answer for this. So pause the video and try to understand what is happening here. Oh wait, before that I'll give you some hint. So this is structure 1 and structure 2, node 1 and node 2, and this is very important point. I'm taking this node 1 type inside this and calculating the size of that. So first size is this, second size is this, which contains this here. Okay, so try to understand and find the answer for this. I think you will come up with the answers, so let's check those. So let's compile this. So the answer is 8 and 12. So that is this last one, E. So if you know structural padding and packing topic, it will be very easy for you to understand this. Otherwise, you will find it hard to understand. So I'll recommend please go ahead and watch my structural padding and packing video, which I will be giving the link in the description field. So let's start this. So as you know that how the structure will take the size. So first of all, it will see which is the biggest data type. This one is the biggest data type. So it will take the multiple of that data type in memory allocation. So when it is going to allocate the memory, it will have in one block we'll write C, another it will be I. So this is also 4 byte and this is also 4 byte. So collectively this is 8 byte. That's why first is 8. So we got this 8 here. That is clear. And if you don't know, this C will be occupied in the first byte because there are 4 bytes, right? So 0, 1, 2 and 3. So C needs only 1 byte because it is character. So C will be actually here only, and this rest of the place will be wasted because I will start after this 3. And why I will start after this 3? Yes, because this is the rule. I is of 4 byte and you cannot place 4 byte inside this. That's why it will start after this. Okay, so I will go from here to here, means 4 to 7. So this was about node 1. Okay, so this was about this one. Now let's create this one. So as you can see, we have this one as the bigger data type in this, but this time it will not create your memory multiple of that number. I mean, it will create the memory like this. First it will check node 1. So node 1 having bigger data type as integer. So it will create multiple of 4 when it will go for the memory creation. Okay, so first will be created for 4 block. It will place this C inside that, and yeah, it will open up this whole thing here. Okay, so node 1 has C, node 1 has I, and then it has this C. So 4, 4 and 4. That's why it is 8 and 12. So 4, 4, 4, it is 12. So this is how it works. So when it is going to decide that what is the bigger element in this data structure, I mean this structure, and it encountered that this one is the biggest one, and then it found that this is not a implicit data type, this is a user defined data type. So it will go and check this data type here, and it will check which is the bigger one. So out of this it found this one as the bigger one. That's why it will create multiple of 4 bytes blocks. Okay, so anyway, this much is coming from top. Okay, this one, because from here to here it is node 1, but we were supposed to calculate the size for this C, and this C is of character type, so it requires only 1 byte. But how much big block we need to create for this? That was the decision we need to make, and that decision will come on the basis of this node 1. So node 1 has this bigger element 4, that's why we'll create this 4 byte. Okay, So I'll clear this. So if we will make this, let's character, in that case, what should be the size for this one? 1 byte and 1 byte, 2 byte only, and this one it should be 3 byte. So total it should be 2 and 3. Let's check that. See, 2 and 3. It means now this is a character, right? So if it is character, let me write that. Then again, it has to decide for this data type how many byte I need to allocate. In that case, it will search for this one, and here the bigger data type is character only. That's why it will create 1, because this C can be accommodated in 1 byte, so that's okay. But what if this is integer? So let's check that. This MCQ is going to be a little big, so let's compile this. Yeah, 2 and 8. And the reason is, this time when it is opening up this one here in node 2, so once if it is open in node 2, we have character C, character I, and integer C. So this time here the bigger one is integer, so the data type, the memory we will be creating in multiple of 4. So this time 4 for this one and 4 for this one, like this. So this much portion is for this one, and then C and I are stored at 0th and 1, and 2 and 3, this is 2 and 3, this place is wasted, and after that this C is coming. So whenever we are going to create a memory for structures, we search the bigger one, the bigger data type. So in this case integer, and if we have any user defined data type like this, in that case we will go there and check, and collectively we will see which one is the bigger one, and we will create memory multiple of that. Not only this, let me create let's create the pointer here. So if I will create the pointer, then what should be the case here? And let me remind you, my system is a 64-bit machine, so for me pointer is of 8 bytes. So now this time I expect answer from you. What should be the answer for this one? Okay, let's check this. Yoo-hoo! So as I said, this one is 1 and 1, 2, but this time it is 16. And why 16? Let's check that. As I told, this is 8 byte. So pointer will take 8 byte. It is not going to check this one now, because this is a pointer of this type. So pointer doesn't need the information of the concrete type, so it's just the pointer, its size is fixed. Okay, so this is 8 byte and this is 4 byte, but total it is 12, but it is giving you 16. Why? As I told you, it will search the bigger size, which is happened to be 8 now, so it will create the memory like this. This is our pointer n, okay, this one, and which will take 8 bytes, and this one is coming here. Half of this is C, this C, and half is going waste. And why this C is occupying 8 byte? It's just because the bigger data type in our structure is having 8. That's why. That's the only reason. And it is doing this because we need this extra 4 bytes for alignment issue, memory alignment, and for that you need to check my structural padding and packing video, in which I have explained everything about that. Okay, so you'll get the link in the description field, don't worry about that. So I think we're done now. So you got it right. Whenever you are asked to create the memory layout, something like this, for any structure or class, and yeah, this whole thing is applicable for C and C++, okay, both. Not only C++, because I'm using this C out and IO stream and using namespace and all, but it doesn't matter. Okay, so whenever somebody is asking you to create the memory layout for these kind of things, you search for the bigger data type and start creating from top. Okay, from here it will work. Whatever is declared first will come first. That's why I told you in the
previous video that you should have data types in sorted order. So before you should write character, and then only you should write integer. Okay, and if you want to write double, then double. Okay, it should not be other way around. It should be sorted from top to bottom. Correct? I think we have discussed enough in this video. So if you like the video, don't forget to hit the like button, dude, and please do comment how did you feel about this video. Was it good, bad, or did you like it or not? I'll see you in the next video, and yeah, make sure you subscribe to my channel if you haven't already yet, so that you will get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye.
Hello friends, this is Rupesh and you're watching CPP Nerds video series on C++ MCQ questions, and this MCQ question is about a threading MCQ question, and this is number 2. And I didn't had much time, so I'm giving this MCQ video today, and these days I'm explaining threading, so this video is about threading. This MCQ is about threading. I'll check your knowledge on threading, and I may surprise you if you are not much into the threading and all, okay? So let's see if you can answer for this question. So pause the video and try to understand what is happening here. And if you happen to find that problem's solution, let me know in the comment section. So wait for some time, you'll get the answer. So 1, 2, 3, 4, 5. I think you would have come up with the answers. So let's check out whether there is some problem in this code or not. So first, let's compile this. So if I'll just simply compile this, it has compiled successfully. So compilation error is not there. If I'll execute it, there is no problem in this code. But wait a minute, don't go anywhere. There is a problem in this code, and I'm going to explain that to you. Can you see the locking order is reversed? First thread. Okay, let's start from the beginning. So we have thread 1 and thread 2. Thread 1, thread 2 functions are different. So these two will start parallelly, and thread 1 will try to lock mutex M1, and thread 2 will try to lock mutex 2, and then thread 2 will try to lock mutex 1, and thread 1 will try to lock mutex 2. Can you see this? And recall there was some problem called deadlock. Yes, this is a deadlock situation here. I'll explain you what deadlock is and why this is a deadlock situation. Let's assume this T1 and T2 started. So this is thread axis, this is thread, and this is time. The possibility is, as we are starting these two threads at the same time, the possibility is not at 1 second. Let's suppose unit is microseconds. This one is 1 microsecond, 2 microsecond, and 3 microseconds. So at 1 microsecond, these two threads were able to lock mutex M1, and this one was able to lock mutex 2. So here you have M2 locked, and here you have M1 locked. Now at this stage there is no issue because M1 was not locked yet, and here M2 was not locked. Okay, so and let's suppose at second microseconds both are trying to lock. This one T1 is trying to lock M2, and this one is trying to lock M1. So M2 was locked already by thread 2, and M1 was locked by thread 1. And you know this, if you want to lock, and if it is already locked, you will wait. So this thread will wait, and similarly this thread 2 will also wait because M1 is locked before. So this is one of the example of deadlock. Deadlock means, let's suppose there are two resources. Deadlock cannot come in single resource, and there are two processes. So this process want to have this while this process is holding this resource. Okay, so this is a resource and this is process. This P1 want this resource while it is holding this resource. So it's like two boys asking that you give me your chocolate and then only I will give my chocolate, and another boy is also telling the same thing. If you will give my chocolate, if you will give your chocolate, I will give my chocolate. Correct? Then there is a deadlock. No one is gonna give chocolate to each other. And the same situation is coming here. And if I will run this, you may not see the problem here because our processor is very much fast that this particular condition may arise in 1,000 times, or it may arrive at first attempt also, but there is a situation, there is a possibility that it may not come in even 1,000,000 times. Okay, but this can come, and if your system, whatever system you have designed, is not deadlock proof, then this is not a good system. And if I want to show you the deadlock, what I have to do is I have to put a weight in between this one and this one. So you can see that it was not failing. It was perfectly fine code. If I'll run this, see, I'm running it so many times, but still it is not blocking. Okay, there is no deadlock. It is exit successfully. Okay, but if you want to see the deadlock, let me include this like this. Okay, if I'll compile this, compile successfully, see, if I executed it, see, my cursor is actually waiting here. Let me just kill this and clear the console and re-execute it. See, it is waiting. System is inside deadlock. It is not going to come outside. So let's see what is happening here. Thread 1, thread 2 started parallelly. Thread 1 logged mutex M1 and went for sleep. Thread 2 logged mutex and went for sleep. Then both wake up and asking for each other's mutex. Okay, and this is not going to happen. Before I was not applying this, then in that case it was not coming as a deadlock, but it is a deadlock because our computer is so fast that whenever it was acquiring the lock of this mutex M1, at the same time it was able to log this M2, and thread 2 was not even started by that time, or vice versa. If thread 2 started first, then thread 2 was able to log mutex, and after that it was able to log mutex M1, and thread 1 was not started by that time. As this thread 2 have logged both, and let's suppose thread 1 is actually reaching here, once this thread 2 have both the logs successfully, then thread 1 will wait here. There is no problem. And once this unlock will happen, it will get the lock and will do the job. But the situation is when thread 1 reaches to M1 and when thread 2 reaches to M2 and logged, and then just after that thread 2 is also looking for this, executing the second statement, thread 1 is also executing the second statement, then in that case it will be the problem. Otherwise it is not the problem. Okay, so the solution to this problem is you should not change the order of your mutex lock. There won't be any issue if you have this like this. There is no possibility of deadlock here because either of this thread will happen to log mutex M1, and if thread 2 logged mutex M1, thread 1 cannot, and if thread 1 cannot, it will wait here, and by that time thread 2 will log mutex M2 and will do the job, unlock these two, and then it will wake up and do the job. So there is no situation that it can have a deadlock here. Let me just place that again, that weight, and we can see that. See, I'll put the weight here again, and I'll put the weight here, and we can compile this. See, it is still in the deadlock situation. See, so that is what the deadlock is. My goodness. Change this one and change this one. Recompile, execute this. See, no issue. Even if you are sleeping, there is no problem. So thanks for watching, and if you like the video, don't forget to hit the like button, guys, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye.
Hello friends, this is Rupesh and you're watching C video series on C++ MCQ questions, and this question is about threading. So this is MCQ 1 related to the threading, and it is really very simple program. If you'll see here, we are creating two threads, T1 and T2, and these are the functions which will become thread. Okay, and then we are joining them and we are returning 0. Everything is cool, right? It is fairly simple program. Now you're supposed to give the answer whether this is going to be the output, this one is the output, or undefined. I don't know what is this undefined here and what is compile time error. Is there any error here? I don't know. Pause the video, check this out. I'll count till 5. 1, 2, 3, 4, 5. I suppose you would have come up with the answers or waiting for the answers. So let's compile this. So if I will compile this, I'll run this. Answer is 1 and 2. Wait a minute, this is not the answer. Even though it is giving you 1 and 2, 1 and 2 is not the answer, because answer is undefined. You don't know which thread will start first if we are starting at the same time, because when request goes to the OS may delay this thread creation and start this one first. Okay, so it actually depends. So that's why it is undefined like this. And notice this, I'm saying if 2 threads requests are going simultaneously, because this is at the same time. You requested this one and then this one. You're not requesting this one and calling some function and going somewhere else and doing some stuff and then you are requesting this. No, you are requesting this one and this one together. Even though it is looking like one after another, but it is together. Most of the time, T1 will start first, but there is a possibility that T2 will start. So let me just show you that. If I'll run this again, see, second time only, I didn't compile, I didn't change anything. I just executed this one more time, and this time thread 2 started first, then thread 1. Can you see that? Here 1 and 2, and now here 2 and 1. Let me execute this again. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. See, now it is 1, 2. Hey, now see, again it is 2 and 1. So that's why it is undefined. You don't know what will start first if you are starting 2 threads together. So we're done here. Thanks for watching. Don't forget to hit the like button if you like this video, because it will help me a lot. Okay? And if you find my voice little bit changed, actually I'm having cold. So this is the reason why I sound little different. Okay guys, I'll see you in the next videos. Bye bye. Keep learning. Have a nice day.